So when we'll get our mechanics corrected paper, definitely on Monday. Definitely on Monday you will get your papers. And also for the first three, I will post the gifts also. For 27 batch, I posted gifts also for 27 batch. 26 batch. Still, I could not check the papers. Definitely on Monday, I will check the papers and based on the marks, I will send the gifts on Monday. Definitely. Right. Okay. Yes, we can start. Right. We'll start. Now we'll start. Okay. Stay focused. Now time is early in the morning. Just now you guys woke up. So therefore till 12 p.m. Till 12 p.m. you should keep focus. In between we'll take one break and today we should work. We'll work. Right. I think last day we just gave a small introduction to light, and I think I discussed properly the background of the light ray stories. What is electromagnetic waves, and then light, visible light region. Then in order to see the objects, the conditions, and also what transparent, translucent, opaque mediums are what, optical mediums are what, and then we talked about luminous object and luminous object. I think I gave an overall introduction, but mainly, right, our chapter starts from angle of deviation. Then I will go from that today. I'll go from that today. Angle of deviation story. Angle of deviation story. Angle of deviation. Right. So only for these 2 weeks, I told you that the time is we are conducting on Saturday morning, but this is not permanent time. Permanent time is usual Sunday. Permanent time is usual Sunday, but for 2 weeks only, I'm doing on Saturdays. If you have a problem, tell me. But I can't change the time. I don't have any other time slots also. But we can do Wednesday night. Better to do Saturday night, right? Saturday morning, right? Right. Angle of deviation. Last day already I explained what is angle of deviation, but again I'll start from there and today we'll continue the story. Angle of deviation. Angle of deviation. The symbol is capital D. Sorry, simple D. The symbol is simple D. If it is minimum angle of deviation, symbol is capital D. You will learn what is minimum angle of deviation in upcoming sections. Right. Mainly now due to an optical phenomenon. Mainly it can be due to a reflection of light rays. If not, it can be due to a refraction of light rays. When you notice, if the direction of that light rays path has changed, then we define angle of deviation as the angle between initial direction of the light ray to final direction of the light ray. That is the idea. For an example, let's say there's a light ray. This light ray is propagating in a direction, this direction. Due to an optical phenomena, due to reflection or refraction. Now the path of the light ray has changed. Now this light ray is moving in a direction, this direction. Earlier it was traveling in this direction. Now the direction of the light ray is in this direction. The angle of deviation means the angle measured from initial direction. The angle measured from initial direction to final direction is what we call as angle of deviation. Is what we call as angle of deviation. This is simple D. Now, but remember now all the time remember, if they're asking us to find the angle of deviation, I told you a super point, kind of trick. It's not a trick, it's the normal story. I told you that always try to arrange initial direction and final direction such a way diverging from a common point. Try to arrange initial direction and final direction such a way diverging from a common point. Now here, that's what I have done. They haven't given, they have only given initial light ray path and final light ray path. What I have done is, I extended initial light ray path like this. I arranged initial direction and final direction. I arranged initial direction and final direction such a way diverging from the common point. See, this is my common point. This is my common point too. This is my common point too. Initial direction, see, look at the initial direction, this direction. Initial direction. And the final direction is this direction. So when you consider these two initial and final directions, they are diverging from point 2. Then measure the angle between them. So then that is going to be the angle of deviation. This idea simple. Now based on that, I think last day I asked you to do those three test me questions. Hands up who got those three, who tried those three, hands up. I tried those three, hands up. Try those three, hands up. Write those three. Right. Now it's not difficult, but I quickly do it. Test me question number 1. Find the angle of deviation. Find the angle of deviation. Story. Okay. Test me. Right. Test me story. Then first question is initially direction of light rays to the right side. Then it's moving direction like this. If you extend the initial direction of the path, this direction. Initial direction, now direction. If you can measure the angle between initial direction of the light to final direction of the light, that's going to be the angle of deviation, simple D. But the given there, they have given this angle as 120. This angle is 120, then we know that if this angle is 120, what can you say about 120 plus D? The angle in a straight line is going to be equal to 180 degrees. Then 120 plus simple D equals 180. Then we can say that. So 120, very simple story. 120 plus simple D must be equal to 180. Then simple D going to be 60. Simple D going to be 60. Right? This question. Simple D going to be 60 degrees. Very simple. Simple D 60. Simple story. Simple. So then next question. Second one is a kind of a reflection. That optical phenomena is, we can tell this is kind of refraction. Initial light ray undergoes a kind of optical phenomena at this point or something. Then its direction changes. And the direction is this direction. But they have given this angle as 60. This angle is 60, this angle is 60. This angle is 60. Have given this angle as 60. Then if you want to find the angle of deviation, first of all, try to extend the initial direction of light ray. Light ray is coming from this direction. Extend the initial direction. If you extend the initial direction, this is going to be your initial direction. Okay. Then arrange initial direction and final direction such a way diverging from a common point. Diverging from point O. Then angle between initial direction and final direction. Angle between initial direction and final direction going to be our angle of deviation. Simple D. Simple D. So then how can I find this simple D? We all know that. Just consider this angle is 60 from vertical opposite angles. From vertical opposite angles, we all know that. This angle is 60. From vertical opposite angles, we all know that this angle also 60. This angle also 60. From vertical opposite angles, this angle is 60. Then I understand that simple D means 60 plus 60, 120. Simple D is 120. Simple D is 120. It's 120. Then next one. Next one. Next story. Next one is third one. That is also not difficult. Third one, initial direction of the light ray is horizontal. Horizontal. Then it undergoes a change in path this way. Again, there's a change in path in this way. The light ray is moving vertical downwards. We want to find the total angle of deviation. Always consider initial direction of the light ray's path, final direction of the light ray, angle between them is angle of deviation. So don't bother with what's happening in the middle. Initial direction is to the right. Final direction is vertical downward direction. Then I consider initial direction right side, final direction downwards. Always try to arrange initial direction and final direction such a way diverging from a common point. Then we understand. If I do this story here, initial direction right side, final direction is in downward direction. The angle between them. Arrange these directions in diverging manner from a common point. The angle is how much? This angle going to be 90. Angle of deviation is 90. Simple is 90. That's it. Simple. So then I think you got a good clear idea about what is angle of deviation. Simple D is 90. Angle deviation story is important because upcoming sections also we are working with angle of deviation. So we will talk in prism's minimum angle of deviation. So there are many stories done. Right, okay. So then we know what is angle of deviation, that story is done. So then next page, now only we are defining what is refraction of light. Already when I was explaining characteristics of waves, under second characteristic, refraction, I have already defined what is refraction. Again, we'll define refraction for light rays also. Same story only, but we are defining for light rays. What is refraction? Simply we know that if you commonly describe, okay, what is refraction of light rays? We know that when a light ray, that is a kind of wave, when light ray enters from one medium to another medium, we notice that there is a change in path of the light ray. That is what we call as normal refraction. Again, I will tell you that when a light ray passes from one medium to another medium, there is a change in that light ray's path. That is what we define as the refraction. But remember, that is not 100% correct definition. Even though generally we define refraction as the change in path of the light ray as it enters from one medium to another, but that is not always the right definition. Because sometimes, some cases, when light ray enters from one medium to another, we notice there isn't any change in the path. But still we say that light ray undergoes refraction. You will confuse this, okay. The right thing is, remember, in refraction what's happening is, refraction mainly, when the light rays enters from one medium to another, actually speed of that light ray changes. So this is what we mainly call as refraction. Okay, definition write down. Definition write down. That you write down. In that you write down. When a light ray travels from one transparent medium to another transparent medium. When a light ray travels from one transparent medium to another transparent medium, comma. The light ray travels from one transparent medium to another transparent medium. Come up. The deviation of its path. The deviation of its path. The deviation of its path. Inside the bracket, write down inside the bracket, change in direction. Change in direction. Close the bracket. Is called as refraction of light. Is called as refraction of light. Is called as refraction of light. Right. Okay. So then now there is a goal point to be discussed. I will explain that story. Now, you know, in the tute, in the left side, there's a given space. In the given space, first, what shall we do? We'll draw a light ray entering from one medium to another, and we'll define all the nomenclatures. That means all the important terms. Okay, start drawing with me. Draw a large diagram, refraction of light ray. Draw the larger diagram in that site. Refraction. Now stay focused till the first break. Stay focused and have any doubt, openly share your doubts and all. If you have any doubt, ask me. Any doubt, ask me. Nicely, we'll do this lesson properly. We'll learn every point properly. Okay. Stay focused and ask all your doubts. Just put some chats and all. Any doubt, even your doubt is a very stupid doubt, also completely all right. You can openly tell because I'm your teacher and think that now you are in a individual session, one-to-one session. Whatever the doubts that you have, ask me. It's a new section. Therefore, don't give me the doubts. If you have a small doubt, ask me. Then definitely I will explain your doubts in the class. Right. Okay. So this is the line, if not the region, which separates both the mediums. So normally we are calling this as common interface. So this is capital XY, capital X and capital Y. We are calling it as common interface. Right. And then we can say this as our medium 1, medium 2. This is medium 1, medium 2. This medium 1 can be air, medium 2 can be water. Medium 1 can be water, medium 2 can be glass. So medium 1 and medium 2. And there's a light ray. That light ray initially traveling in medium 1 and suddenly enters to medium 2. That's what I'm going to draw it. Initially, this light ray moving in medium 1. So then this light ray we call as incident ray. This light ray we call as incident ray. Let's name this light ray as A light ray. Normally the point where light ray incident at the common interface, we call it as incident point. Point O, we call it as incident point. XY is common interface. Then point O is incident point. This light ray we can name as AO light ray. That means incident light ray. At the incident point, if you draw a normal line to the common interface, just draw a perpendicular line to the common interface at the normal. That is what we call as normal. This is what we call as normal. This is we call as normal. This line we can tell it as O. This line is MN line. This is point capital M. This can be point capital M. MN means a normal line. Then this is medium 1. Medium 1. Common interface. And this is normal. Normal. Incident ray. Incident ray. ray. Okay. So then just think that if there isn't any medium 2, just think this entire region is medium 1, then we know that this light ray's direction of the light ray would be this direction. This light ray would have moved in direction. This light ray would have moved in direction. This direction. But we know that since this light ray enters from one medium to another at this incident point, then as per the definition, as per what you explained, sir, definitely path of this light ray should be changed. I draw the change path. The now path will be this direction. Its initial direction of the path is in this direction, but now its path is in this direction. Normally, we call this light ray as our refracted ray. This light ray we call it as refracted ray. This is point capital B. Point capital B. Point capital B. This is our medium 2. This is our medium 2. Medium 2. Medium 1, medium 2. But remember, the most important thing is sometimes the easy things only we do lots of mistakes. The most important thing is students still you learn the stories in all levels also. But if I ask you what is incident angle and what is refracted angle, some people mistakenly mark. Sometimes in a question also they can ask some tricky. They can give different angle and they can make you confused that as your incident angle. Some people really get caught into that traps. You don't be that. Remember, incident angle is always these angles, incident angle, refracted angle, they all are measured from normal to the incident ray, normal to the refracted ray. Then, if you measure the angle from normal to the incident ray, this is what we call as incident angle simple line. If you measure the angle from normal to the refracted ray, this is what we call as simple R. I'll ask a question. What can you say about this angle? Reply everyone. Reply everyone. Reply everyone quickly. What can you say about this angle? What can you say about this angle? Reply everyone. What can you say about this angle? This angle. Reply. That is going to be the angle of deviation. I explain. Initial direction of the light ray is in this direction. Now direction is this direction. The angle between initial direction and now direction going to be the angle of deviation, sir. Angle of deviation, sir. Right. Right. Finished drawing. Hands up. Who finished drawing? Once you finish drawing, hands up. If you finish drawing this diagram, raise your hands. Now, please raise. If you finish writing something, raise your hands. Then we can go to the stories. Now, I reduced the amount of note that you are writing also. So we'll come to this tutor and please tell me your feedback. Whether we'll go in this approach or we'll go in a usual way. But now the tutors are quality tutors. Refracted ray. If you finish drawing, raise your hands, all of you. Finished on the diagram, raise your hands. Once you finished, raise your hands. If you finished, raise your hands. If you finished, raise your hands. And in the tute, if you don't have a tute, can someone share that PDF in the groups also? Can someone share the topics PDF in the groups? It will be better if you don't have a PDF. Finished drawing, hands up. Based on your how many finished only, I can do the next story. And then we'll define. Okay, many finished. Define what is simple line. Simple line. Now in here simple line. Simple line is incident angle. I is incident angle. Right on. What is simple R? Simple R going to be refracted angle. Simple R going to be refracted angle. What is simple D? Simple D means we all know that angle of deviation. Simple D, angle of deviation. Simple D, angle of deviation. AO. AO. AO is incident ray. Incident light ray. AO means incident light ray. What is OB? Refracted light ray. OB is refracted light ray. OB, refracted light ray. Then point O. What is point O? Point O is incident point. Point O is incident point. And the capital MN going to be the normal. And capital XY going to be the common interface. Capital XY going to be the common interface. Right, okay. The next one, look here. Then C1, C2, lambda 1, lambda 2. Now, sir, as you explained, sir, when a light ray undergoes a refraction, you told us mainly what happens, mainly, definitely, if they mention a light ray undergoes refraction, definitely speed of that light ray must be changed. When a light ray enters from one medium to another, definitely speed of the light ray must be changed. So then, if I consider this light ray speed in medium 1 as C1, remember, the speed of the light ray in the medium 2 definitely C2. Definitely C2. So then I have a problem. These light rays are also waves. Now you told us speed is changed as it enters from one medium to another. So what would happen for the frequency of the light rays and what will happen for the wavelength of the light rays? Remember, during a refraction, during a reflection, frequency doesn't change. If it is a red color light ray, same red color light ray is propagating in second medium also. Remember, during a refraction, frequency is a constant. Frequency of the light rays in the medium 1 is also F. Frequency of the light ray in the medium 2 also F. Important, huh? Important. So then, okay, free speed changes, frequency constant. So what can we say about the wavelength? We know the equation, universal equation that can be applied for any wave. V equals F lambda equation. According to V equals F lambda equation, sir, frequency is a constant. Frequency constant. Then, sir, when speed changes, definitely wavelength must be changed. For example, sir, when speed increases, wavelength of that wave must be increased. Then you know the story. When the speed increases, when the speed changes, wavelength changes. That idea. During refraction, remember. Now speed and wavelength both changes. Speed of light in medium 1 is C1. Wavelength, corresponding wavelength is lambda 1. Corresponding wavelength lambda 1. Speed of light ray in medium 2 is C2. Corresponding wavelength lambda 2. Right. Now, in that page number 4, I have given a goal point. The goal point is the reason for refraction is that the velocity of light changes when it passes from one medium to another. Highlight the entire point. During the reason for the refraction is the speed. Due to the change of speed only, refraction happens. Highlight the entire point. Highlight the entire point. Highlight. And also what you do, write down somewhere else. Write down somewhere else. Okay, write down somewhere else in this, in here or whatever, in here or wherever. Write down. During a refraction of light. During refraction of light, comma. The frequency of the light ray, doesn't change. During refraction, the frequency of the light ray doesn't change. Inside the bracket, it remains same, close the bracket. It remains same, close the bracket. Red color pen. It should be in red color pen. It remains same And next point also write down. Different color pen write down. Somewhere else. Different color pen. The wavelength of the light. changes. The wavelength of the light changes during refraction. During refraction. Since speed of the light changes, since speed of the light changes, the wavelength of the light changes during refraction, since speed of light changes. Then if you want to write down this equation, show that v equals f lambda, f is a constant, then when v changes, lambda changes. C1 lambda 1 f, C lambda 2 f. That story is done. That story is done. Nothing to learn new. Nothing to learn new. Nothing to learn new. Right, okay. So then the next page, page number 5, then we'll define what is incident angle properly. Now we know what is incident angle and what is refracted angle, what is medium 1, medium 2, we'll define that. Write down. Under incident angle, write down. Under incident angle, write down. Write down. In that given space, the angle between incident, the angle measured from. The angle measured from normal to the incident ray. The angle measured from normal to the incident ray. Under refracted ray, write down refracted angle. Under refracted angle, write down the angle measured from normal to the refracted ray. The angle measured from normal to the refracted ray. The angle measured from normal to the refracted ray. Now remember, now still many have a confusion about this medium 1, medium 2. Remember, always we put as medium 1 for the medium where light rays enters first. If not, one can tell that, remember, medium 1 means always the medium where incident ray exits. Remember, always your medium 2 going to be the medium where light ray enters secondly. If not, the medium where refracted light ray exits is what we call as medium 2. Please don't define medium 2 as medium where refracted ray exits. Please don't define the okay. Please don't define your medium 1 as. Please don't define your medium 1 as medium where refracted ray exits. Please don't define your medium 2 as medium where incident ray exits. Then it make you confused. Remember, hereafter, medium 1 means the medium where light ray enters first. If not, the medium where incident ray exits is our medium 1. The medium where refracted ray exits. If not, the medium where light ray enters second, that is what we call as medium 2. Write down. Under medium 1, write down. Under medium 1, write down. Under medium 1, write down. Medium 1, write down. The medium where incident ray exits. The medium where incident ray exits, or the medium where light ray enters first. The medium where light ray enters first. The medium where light ray enters first. Okay, that is okay. If I'm too much speed, tell me. If I am too much speed, I'm telling to tell me. Okay. Okay. So what to write in the blanks of C1, C2? Okay. Now what did I tell you? Okay. C1 means speed of light. Remember, write down C1 means here speed of light in medium 1. C1 means speed of light in medium 1. Speed of light in medium 1. C2 means what? C2 means speed of light in medium 2. If I miss something, tell me. Not family any. C2 means speed of light in medium 2. Then what is lambda 1? Lambda 1 means what? Wavelength of the light in medium 1. Lambda 1 means wavelength of the light in medium 1. What is lambda 2? Wavelength of light in medium 2. Wavelength of the light in medium 2. If you have a doubt, you want to reply for that ACE Academy. Reply for ACE Academy. Reply ACE Academy. Now we were writing about medium 1, the medium where incident ray exits, or medium where light ray enters at first. The medium 2 means write down the medium where refracted ray exits. The medium where refracted ray exits. the medium where refractory exits or the medium where light ray enters second. The medium where light ray enters second. Secondly, the medium where light ray enters secondly. Secondly, that is also done. That is also done. Done. Now I told you that story. Just because, remember, just because we can't define the refraction as always, sir, when there is a change in light rays path, then that is the refraction. We can't always tell that 100%. Because remember, if you define the refraction as the change of, if you tell the refraction as the change of light rays path as it enters from one medium to another, that is not a good definition for refraction. Why? The reason is there are some light rays. Remember, there are some light rays when they're traveling from one medium to another, they travel without any deviation. The best example is remember, this is an important case. There are some light rays when they enters from one medium to another, they don't show a deviation. Their path is not deviating. They are following same path. They are following same path. This story. Right? Look here, our common interface. This is our common interface. And now I'm going to draw a light ray, incident ray, perpendicular to the, now see, now I'm going to draw an incident ray, that ray is perpendicular to the common interface. Incident ray is perpendicular to common interface. Then let's see what will happen. This is my incident ray that is perpendicular to common interface. Remember, if the light ray perpendicular to the common interface, that type of light ray never undergoes a deviation. That light ray perpendicular to the common interface follows the same initial path even though it is moving from medium 1 to medium 2. Right? This light ray don't show a deviation. Then one can ask, is that mean this light ray doesn't undergo refraction? Remember, the refraction means normally we say refraction as the change in the path of the light ray as it enters from one medium to another. But remember, that is not the right way of defining refraction. The right way of defining refraction is, remember, the change in speed of the light ray as it enters from one medium to another. The right definition is the change in speed of the light ray as it enters from one medium to another. That is what we call as refraction. But in this story also, yes, sir, if the light ray is perpendicular to common interface, then this light ray doesn't undergo any deviation in the path. It follows the same initial path. That's correct. I'm going to ask you a question. This is medium 1. This is medium 1. This is medium 1. I'm going to ask you a question. This is going to be medium 2. Raise your hands. How many we say that? Sir, in this scenario, since the path of the light ray doesn't deviate, raise your hands. How many we say? Sir, speed of the light ray in medium 1 and speed of the light ray in medium 2, they are same answer. Raise your hands. How many we say? In this case, sir, speed of the light ray in medium 1 and speed of the light ray in medium 2, they are same answer. Sir, even the path is not changed, even though the path is same as it enters from medium 1 to medium 2, but still there is a change in its speed. The speed in medium 1 is C1, so speed in medium 2 is C2. Hands up. How many we say? That is the idea. That is the idea. Then goal point I have given in that story. Goal point I have given. The light ray. Now look at the goal point. The light ray incident perpendicular to the common interface does not change direction, but it still undergoes refraction because its speed changes. Highlight the entire goal point. Highlight. And also in that diagram you can see mistakenly marked as capital M1, capital M2. Rather than okay, capital M1, M2 is okay, medium 1, medium 2. Just write on there, medium 1, medium 2. And also when you are drawing a light ray, remember, if you just draw a straight line, If you just draw a straight line, remember that is not a light ray. Because I told you last day in the definition, light ray means you should draw a straight line and arrow must be pointed in the direction of light propagation. If you forget to put an arrow, they won't give marks also in your A-level exams. So therefore, in the diagram, arrows are missing. Please mark the arrows. These two arrows like this. Like this. Like this. Okay. Right. And that story also okay. That story also okay, right? Okay, the next story. Next story. Next story. So then, okay, sir, it's very clear so far. It's not an issue. Everything is nicely. Everything is going smoothly only. We start from angle of deviation. The refraction is already we defined in the previous classes. But it's not a new story for us. But this ray diagrams might be a bit new, sir. This is a kind of special point. The important point is due to refraction frequency constant, the speed changes. That is the must. That is the reason behind the refraction. And then, sir, you taught us wavelength also changes. This is the special case story also we know. Then, sir, now I have a doubt, sir. My doubt is, sir, now just consider, sir, when the light rays, you told when the light rays, as we know that already, when the light ray enters in different mediums. For an example, light ray propagating in air, it's a medium, transparent medium. If the same light ray propagates in water, that is also kind of transparent medium. Sir, if the light ray propagating in the glass, that is also a transparent medium. Now you know what is medium. Then tell me, raise your hands, how many we say, sir, this air, this water, this glass, they are coming under transparent medium. They are coming under transparent medium. Then we all know that, sir, as per my understanding, when the light ray is passing from air, water, glass, the speed of the light ray is changing. That's obviously. Because as light ray enters from air to water to glass, the speed of the light ray changes. Remember, based on the speed of the light ray in the relevant mediums, what we are going to do is we are going to divide the mediums into two different categories. One is rare medium, other one is dense medium. Rare medium, dense medium story already we learned in characteristics of waves also, but again we are defining based on the speeds of the light rays in mediums, we are categorizing mediums into two categories. One is rare medium, other one is dense medium. That story. Now we talk about now. See, depends on the speed of the light in the medium. Mediums can be categorized into two. One is rare medium, other one is dense medium. Right? Mediums. Rare dense. And there will be a small test, means kind of small MCQ tests also there. Therefore, careful listen what you learn now. From the lessons that you learn, from the section that you learn now, so there are some MCQs to be done. And then I will give you 5 minutes and I will ask you to do within that 5 minutes and I will check how many MCQs you got correct. Therefore, stay focused. Rarer, other one is denser. Denser. Not new story, we know the stories. Denser. We have to do lots of questions in this section. Lots of questions. Plan to keep some extra classes for theory. Right, bond to center of gravity stories and some others to be given for previous sections. Openly talk. If you have doubt, openly talk. Your doubts are warmly welcome. So why do we specify as transparent medium? Is there a specific reason? Can't it be to translucent or opaque mediums? The thing is, now that's also kind of a good question. Now remember, mainly in our syllabus, we talk about refraction of light rays, especially in transparent medium. There's a reason why. Can we talk the refraction in opaque medium? We can't talk about refraction in opaque medium. Why? Because light rays won't propagate in opaque medium. What about translucent mediums? Translucent means light rays are partially passing through that medium. We can't 100% guarantee a given light ray really passing through that medium or not. We can't give a 100% guarantee in translucent. Opaque means sure light ray won't refract, because in order to refract, that light ray should propagate through that medium. So just think that this is air, it's a transparent medium. The translucent, in order to propagate the light ray through your house wall, can the light ray propagate through your house wall? Then the house wall is kind of a glass. then someone in the other room can see what you are doing inside the room. So therefore, remember, if it is opaque medium, since the light ray is not propagating in the opaque medium, we can't talk about refraction in opaque medium. Translucent, we have not a 100% certain. We're not sure that whether the light ray enters to the translucent medium or not, right? The light ray enters to translucent medium, then it undergoes refraction. The light ray is not undergoing translucent medium, then we can't talk about refraction. That's why we are not talking about refraction for translucent opaque mediums. Only we are talking refraction in transparent mediums in our syllabus. Right, me? Right, okay. Right, okay. Rare medium is a medium story. Medium two types. Under the rare medium, we'll write down. Under rare medium, we'll write down. Already you know that normally what is rare medium. Okay, ratio and how many we see now? How we define based on the speeds of the light rays in the medium, we define rare and denser. Ratio and how many we see? Ratio and how many we see? So rare medium means the medium where speed of the light rays maximum answer. Ratio and how many we say? The rare medium means the medium where speed of the light rays higher. That's correct. Ne? Then the medium where speed of the light ray is lower, that is the denser medium. Same small stories. But to maintain a good knot, we have to write everything. To write a good knot, because remember, the most important thing is the knot. If I ask you that in your A-level period, who is your best friend? Who is your best friend in your A-level career? Not for the entertainment, or I'm not talking that stories. In your A-level career, when you are reaching your goals, there is one best friend with you, that is your knot. So therefore, properly maintain your knot. Normally, I am giving a proper knot. I have checked with my knot with other teachers' notes also, because I continuously check what is lagging in my side, what is the pluses in other teachers. If I notice a plus in another teacher, what I do, I don't hesitate to copy that even. Right? It's not my natural positive. Even for the continuous success in my classes, what I do, if I notice a teacher something is positive, then I copy even. Right? So normally I just check that when you compare the notes, normally my notes are normally good. My notes are normally perfect. Some notes are there, some teachers, there are some popular teachers also. There are notes, not lots of stories not included. They just explaining also up and down briefly. Physics, we can't do that story. A to Z, you should know everything. So therefore, remember in your A-level career, the best friend who is going to with you, who is going to stay with you till A-level is your notebook. Therefore, maintain your notes properly. Maintain your notes properly. Because the problem is, if you're doing first shy, that's completely all right. If you're doing first shy, then you all have no mood of doing second shy, right? That's the obvious thing. We have enough time for the A-level exam. Even your level is W, we have enough time to make the W to be on A. This time is possible. Any level. Even your level is this level also is possible. But remember, when you're doing first shy, some of you don't go classes. If you are going first shy, some of you don't go classes. Some of you are only going for paper classes. Right? Going another class, theory class again. If you missed your notes, if you don't have a proper note, then what happens? Then you might have to go again theory class. Again theory class, again revision class, again paper class. Again, you can't control, you can't manage your time. Let's say now, okay, no, sir, even I don't have a proper note. My friend has maintained a good note. I'm going to take her note. Remember, you can't 100% sure whether your friend's note also 100% perfect, right? Sometimes your friend absent for classes. Sometimes your friend might miss some recordings to watch. What would happen in case if an MCQ asking from that question, that section? And also remember, even your friend maintains a good note, that is not your note. The most effective note to study is your own note. Even you refer another one's note, your friend's note, handwriting is so beautiful. She has written a nice note, everything is very clear. But remember, that's not your note. Therefore, remember, again, it's not effective. Therefore, maintain your note properly. Write a medium, write down. Write a medium, write down. Write a medium, write down. Write down. Write down. The medium in which velocity of the light is high. The medium in which velocity of light is high. relative to the other medium. The medium in which velocity of the light is high relative to other medium. The medium in which velocity of the light is high relative to other medium. Okay. Dense medium, write down. So now you can write down the medium in which velocity is low relative to other. Highlight rare velocity high. Highlight denser velocity low. Highlight rare velocity high. Highlight denser velocity low. And the goal point also, I specifically marked that. In that goal point, highlight rare medium velocity is higher. I have marked in that goal point also. Dense medium velocity is lower. But remember, now when you consider air and water, okay, I'll ask you a question. Look here now, stop doing and look at here. Look at what I'm doing. Right, sir. Your definition is very clear. Rare and denser definition is very clear. So now let's consider now, for an example, water and glass. When we consider water and glass, ratio and how we say velocity is larger in glass and if we consider water and glass, ratio and how we say velocity is large in glass. Just assume, okay, how many we say that velocity of light in larger in water and water. Just consider water and glass. Now, sometimes you have no proper idea, right, sir? Okay, I understood what is rare, what dense medium. But suddenly, if you give two mediums, let's say, okay, forget about water and glass. Just consider coconut oil and let's say now spirit. Spirit is a kind of liquid, right? Sprite, coconut oil and Sprite. Raise your hands. Somebody will say. Now tell. Raise your hands. Somebody will say when you consider that's a liquid kind of coconut oil, but not yellow. It's transparent. Okay. Raise your hands. Somebody will say when you consider coconut oil and that spirit, that's also kind of liquid. Hands up. Somebody will say velocity of light is larger in coconut oil and velocity of light is larger in spirit and okay. The idea is what I wanted to tell is sometimes suddenly when they give two different mediums that we are not very familiar, deciding which medium is rare, which medium is denser is somewhat difficult. So we don't know. We can't tell that this medium has larger velocity, therefore this is rare. This medium has smaller velocity, therefore it is denser. We can't tell that. Remember, there is one trick. There is one trick in that story. That's not 100% true. But you can for most of the mediums you can apply the story. Normally, remember the medium having larger density, they are denser medium. Remember, when you compare two mediums, the medium having larger density, they are denser medium. The medium having smaller density, they are the rarer medium. That is not always correct. We can't apply that for all the mediums. For the most of the mediums they give in the question, yes, we can tell that the medium having lower density, rarer medium. The medium having large density, dense medium. For an example, air and water. Without a doubt, we can tell that air density is lower, water density is larger. Then air should be rarer medium, water must be denser. So when you consider glass and water, we know glass is denser than water. Then glass is a denser medium. Then water must be rarer medium. That's story. And also write down somewhere else there. Now, in the goal point I mentioned, rarer medium means lower density. See, denser medium means large density. Somewhere write down. Like this. Write down. The medium which has large density relative to other medium. The medium which has the large density relative to other medium is denser medium. Is denser medium. Is denser medium. The medium which has the smaller density relative to other medium. The medium which has a small density relative to other medium is rarer medium. Rarer medium. That is okay. Okay. Story okay. Right, okay. This story also okay. Right? Then now tell me now examples. I have given two examples. Example one is light ray, not light may. Light ray in air enters to water. Then just write down there. Air is rarer, water is denser. Next story, light ray in water enters to glass. Write down there. Water arrow, rarer, glass is denser. When you consider air, that is rarer. When you consider water, is denser. Denser. Next story. Light ray in water enters to glass. Then water is rarer, glass is denser. Then case one, goal point. When light ray travels from rarer medium to denser medium, light ray bends towards normal. Highlight that story. The next story. Highlight that entire story. Sometimes this is you never learned. In all levels you might have learned. First time only you are learning in A level. Highlight when light ray travels from rarer, not point, rarer medium. At that point, when light ray travels from rarer medium to denser medium, light bends towards normal. Light bends towards normal. Turn next page. Right, okay. This story, remember, this is important story. The next idea. Step by step, we are learning the theory. Next story. Again, in the next page, you draw the diagram. This is your common interface. XY. And let's say now light ray. This is our normal. I know the normal also. This is the normal. Normal. Stay focused. Stay focused. Then if I draw my incident ray. Incident ray. Remember this medium one. This is medium one. I consider medium one as rarer medium. Now you know what is rarer medium. My medium 2 is denser medium. My medium 2 is denser medium. Medium 2 denser. Listen carefully. Listen carefully. Denser. Then incident angle is I measured from normal to the incident ray. This is incident ray because this ray is in medium 1. Then if there is no second medium, the initial direction of the light is this direction. Okay. The initial direction of the light is this direction. Remember, if the light ray, this is must, if a light ray, you must learn by heart, if a light ray enters from rare medium density medium, high speed medium to low speed medium, low density medium to high density medium, this light ray should bend towards normal. This is the path of the light ray. If there is no way to second medium, this is the path of the light ray. If it undergoes refraction from rare to denser, this path should be bent towards the normal. Bent towards the normal. If no second medium, this is the path due to the refraction. As it enters from rare to denser, this path should bend towards normal. This path should bend towards normal. Is a normal. Okay. Must. Are they normal to the different ray? R. Okay. So the next page you should draw this. Next page you should draw it. Rare to denser. Draw it. Rare to denser. Next diagram, denser to rarer. Next story, denser to rarer. If I draw that story also. Learn theory. In the beginning, we want to learn a theory. Anyhow, we want to learn a theory. Danger rare. Second story, danger rare. Danger rare. Any doubt, ask. Any doubt, ask. Right? Okay, any doubt, ask. Today, everyone come and write the paper. Don't tell sir this, that, sir, and want to turn on the camera also. Hereafter, just turn on your camera. And if you guys don't like to show your faces, put a mask or something. If you have an issue, tell me. We'll see. But better to do on the camera and just write. Then you get the exam. Okay, look here now. I want to tell the story. Now, currently, now you know how these exams are conducted. I just share the paper in the WhatsApp. For example, if I'm keeping the exam at 8 a.m., I send the paper at 7:55 WhatsApp. Then I told you take 2 hours and exactly finish at 10 o'clock and send the paper before 10:05. That's what I do. Then I download your paper and I take printouts and I check your papers. Then I give marks. But now I'm talking with I'm talking with that Ace Academy people, and they said they agreed and they said they will implement soon in. They said they will implement soon in within 1 2 weeks. I don't know when. Then this paper pattern now. If I tell just send the paper at 10:05, you have no that much big stress. You don't really get that exam atmosphere, right? So therefore, now what we are going to do is in the website itself, our usually Ace Academy website, where you see recordings and all. What we are going to do is you should download the paper only through website, because let's say exactly 8 o'clock. Already I upload the paper in the website. But till 8 o'clock, you can't download the paper. They don't allow you to download the paper till 8 o'clock. You can start download the paper exactly at 8 o'clock. Then you download the paper. From the moment 8 a.m., 8 a.m., from the moment 8 a.m., you can see in the website there's a timer. That's if the exam time duration is 2 hours, the timer shows 2 hours. Exactly at 8 a.m., the time shows 1 hour and 59 minutes, 1 hour and 58 minutes, 1 hour and 45, 1 hour, 45 minutes, 30 minutes, only 1 minute. Likewise, before 2 hour finishes, definitely you want to write everything and you want to upload that paper in that website itself. Like how you upload your slip, I will give a kind of space. Within that time limit, you have to upload the paper within the time limit. When the timer runs, then the timer finishes, you can't upload. And that paper is not going to be accepted. Then when you do a paper like that, you will feel a big stress. So that is also we are implementing. Already I implemented using a different website for my 23 batch people. But using two different websites, two different apps and problem. So this will also be implemented. Then it's better. Then better. They're very systematic rather than putting in the WhatsApp. This is much professional way also. Then nice. A nice story. What about directing the camera for the paper? Now some people have some difficulties. Some people have now want to direct the camera means there should be a kind of hold. If not, you want to keep the camera like this, then phone slip down, phone falls down. Then no need to go to that level, because you all are a level matured people, right? You are not like that kids, so you don't copy, and even your copy also doesn't matter. Even you copy and you get 100 marks also doesn't matter. It's up to you, right? It's up to you, and you can't get 100 marks also. Therefore, now you know what is the intention. You know why you are paying money and why you are writing the paper. You know what is the real intention. To know where are you, to evaluate yourself. That's what you are coming and paying money and spending your own time. 2 hours sitting in your own chair and letting no one to come inside the room. I am writing a paper. Why you are doing that? You are doing that to evaluate you. Then I don't think that ALL people they are copying. And for an example, let's take two students, Akshita and let's take Amaya, right? If not Akshita and Zuha, someone, anyone, then tell Akshita, what is the answer for that question? Tell me, WhatsApp me. Then Amaya, do you know that one's answer? Send me. Then Zuha, what about you? You found that question to answer. Tell me. You guys not doing like that, not a kid like that. You are not a kid, right? So therefore, no need to go to that level. Fine. Just ultimate goal is get the hands-on experience. Because online classes, if you can come physically and write the paper, no need. Very simple. What you want to do is depends on the home facility also. There's a small problem. Otherwise, very simple. If you have a room in your house, if there's a room, tell your mother, I am writing a paper. You are spending this much of money, mother, every month. You are spending this much of money, mother. Please, only for these 2 hours. You want me to take a result, right? Then please don't let anyone, especially that little guy, that brother, that Vesam. Okay, please tell those people not to come inside my room. If that one come, I hit his back and I punch him. Tell I am writing an exam, mother, every time. Then no, don't allow anyone to come inside the room. Inside the room, oh, there's any space. Then tell please don't come. I'm writing a paper. You seriously, you imagine in our dreams, when we dream, sometimes when we close the eye and when we sleep, sometimes we imagine the things that we like. Sometimes I do. So what you do, imagine that really you are in an exam hall. You can imagine, right? You are in an exam hall. Then I'm writing a paper. Then you have bring a water bottle and stopwatch timer. Do like that. Do like that. Just put that commitment, right? Then no issues with writing papers through online also. Most important thing is writing as well as writing the paper. First of all, self write, because if you try a paper only, you know that how many questions you can do. Sometimes you think that you can do that question, but when you read the question you feel like you can do, but when you start trying you can't do. Sometimes you feel like, yeah, this question I know how to answer, and you get an answer, but when you come to the discussion you feel like the way that you thought is wrong. Therefore, first of all, you should write the paper and you should come to the discussion. Then only you know, when I do the discussion, I thought this question this way, but sirs approach this way. So we can use question different way also. I have got the answer in different way. So what about your way and my way? Both whose way is correct, both ways are correct. Then only you get the 100% benefit of joining for discussion, right? And the next thing is, remember now, I'm trying for 26 batch to do this properly, but did your support? Did your support? Now, what some people do, they come and write one paper, two paper, three paper, and what they do, then they don't come. And some people, they don't like writing essay papers. Some students, they don't like essay papers. They only like to write only MCQ papers. Don't be like that also. Because 50 marks given to MCQ, 50 marks given to essay in your L exam. Right? If you only come and write MCQ papers, if you don't write essay papers, that means sorry. Sure and short, definitely you can't perform very well in your essay paper. So therefore, equally give priority for both the papers. Now, what I do, I will post all now. This tomorrow, still I could still you didn't receive the tudes. You can't have the papers, but next week you will get everything. And then you can write the paper. I will give the workbook. I will give the answer sheet. You don't want to take a piece of paper and you don't want to mark. MCQ paper means 1 to 50, 1 to 25 MCQs. You don't want to take a piece of paper and you don't want to mark in a paper and you don't want to send me. I will send the markings. I will send that answer sheets. I will send, if it's the MCQ paper, I will send the answer sheets. And I will send the, if you're writing the essay paper, I will send the workbook to write the essay paper. Workbook. You don't want to take some papers in your book and you don't write the paper. I will send it. I'll send. You only want to do is in that time period, use the book and write and send me. And to write the reviews in the discussion, to write the, if that paper one, I attach MCQ, the correct answers. I attach the correct answer sheet. And to write description, to write the reviews in every question, I send the separate review book also. I send. You only want to stay in the discussion and you only want to fill in the blanks. Right? The remaining I am doing. Okay? Right. Where were we actually? The time is 9:17. I was talking about, okay, right? Okay. Okay. So far, okay. Do you understand what I'm saying? Do you understand? Right? Okay, this story. Okay, I forgot. Yeah, I forgot to come here. Then see. Okay. Now, if the light ray enters from dense to rare, I do the common interface. This is my common interface. XY. And the normal, the normal, normal. If I do the incident ray, the incident ray, this is the incident ray. Angle measured from normal to incident ray is incident angle I. If there is no medium 1 and medium 2, if there is no medium 2, the direction of the light ray would be, the path of the light ray would be this direction. What happens? This is medium 1 is now denser. Medium 1 is denser. Medium 1 is denser. So denser medium. Medium 2 is rarer. When light ray undergoes diffraction from denser to rarer, denser to rarer, medium 1, medium 2, denser to rarer. Then remember, the path of the light ray bends away from the normal. This is the normal. This is the initial path. After the refraction, the light ray refracts from denser to rarer. After the refraction, the light ray bends away from the normal. This is the initial path bending away from the normal. Then the light ray, refracted ray would be this direction. You got it? Rarer denser toward the normal, denser rarer away from the normal. So this angle is going to be simple R. Angle measured from normal to refracted ray going to be simple R. Simple R. And tell me what is this angle? This angle is our angle of deviation. Initial path, final path. This gap is angle of deviation, simple D. In this scenario, can you mark the angle of deviation? This scenario, please mark the angle of deviation. Sir, initial path is this direction, sir. This is the initial direction. This is the final direction of the light ray. Sir, initial direction to final direction. So this angle is going to be our angle of deviation, simple D. Simple D. And what you do now, that case 2, goal point, when light ray travels from denser medium to rarer medium, comma, light ray bends away from the normal. Highlight that sentence also. Highlight the sentence also. And draw this diagram in this space. Draw it quickly. Once you finish doing, raise your hands. Once you finish, raise your hands. Once you finish, raise your hands. So if you don't mind, can you give a rough idea on how many marks do we need to score for each subject to get Z score or no? 2.4. Oh. Z score 2.4 means if you are a bio student, 2.4 Z score means you should get 3 A's. 3 A's means at least let's especially physics is the deciding factor for the Z score. If you are a bio student, if you can score, let's say now, chemistry 75 and biology 75, physics 75. Let's say that guy is that score is let's say 1.9 something, 75, 75, 75. His score is let's say 1.8 or 1.9 something. Another one is scoring chemistry and biology 75, 75 marks. But that student's basics marks is 80. Okay, we'll come like this. Biology, chemistry, physics. First student A got say 80 marks for chemistry. Remaining 2 subjects, biology and physics 75, 75. Bio and physics 75, 75. And chemistry 80 marks. Chemistry 80. Other 2 subjects 75. Student B, the student has got chemistry and biology 75, 75. Physics 80. Student A's score is how much? The total marks of both of them are same marks. Total marks same. But student A's score is let's say 1.9 something. Student B, who scored more marks in physics, his score can be 2.1. Remember, even the same marks, it depends on the marks that you score in physics subject. His score is changing. Right? Normally, if you go to get 2.4 Z score is it's a big Z score. If you are getting a Z score 2.4 means your rank will come under below 200. Your island rank, I on district rank, but depends on the your district. You know that even the now your district is Nuvareli. Normally, the even the district first in Nuvareli also he's scoring 1A 2B in Nuvareli side. When it comes to Colombo side, even district hundreds result is 3A and result score is 2.8 in Colombo. Colombo district, district hundreds result score is 2.8 something, but his district rank is 100. In Nuvareli, student's result is 1A 2B, his result score is 1.4 something. Remember, depends on your area, right? Depends on your area. Okay, my place district quarter is 2.4. That's why. Where is your place, madam? What is your district? No, that is varying. Ratnapur, no, Ratnapur area normally Z score is not that much big. Okay, you can't tell that. It depends. Just now Ratnapur area means that is not that much. It depends. It varies. Every year they are telling that Z score criteria. They give that quota. Quota varies from year to year, right? And some way, if the exam is easier, sometimes the score of all students will increase. In that case, they increase the quota. That depends like that. You don't worry with that now. If you try to get 3 years, if you try to get 3 years, then you can keep a faith on getting for the medical faculties from areas like Ratnapura. If you are a Colombo one only, you want to suffer. If you are from Colombo, then you want to suffer it. Why? Especially these medical faculties to enter at least low demand medical faculty in Sri Lanka. If you are coming from Colombo district, even you get 3 years also. Even you get 3 years also. Sometimes most of students they don't select to medical faculties, even though you get 3 years. Because when I was doing my A levels, I knew a girl. Single girl, and she's a Sinhalese. And first shy, she's senior, I think. First shy also she got 3 years. She got 3 years first shy. 3 years. Second, then ISET score was not sufficient to select to a medical faculty from what? It depends on the year also. Depends on the year also. She has done second shy also. She also got against 3 years. Not sufficient to enter for a medical faculty. And third shy also she did done. I don't know what happened. She got 3 years. I don't know what happened to her. That's the thing. That does not mean that in Colombo district you are 26 exams, you get 3 years. That does not mean that you won't select to medical faculty. It depends, right? Something depends. Study well, try to score more. That's it. Don't fix the target. Now that film, I'll talk. I'm talking more than 10 or 15 minutes. Okay. Now remember, when you define a goal, it's a problem. Okay. Now you are defining a goal, and if you define a goal, yeah, you must get 3 years. That's obvious. It's a clear goal. But if you define, I will take for a Z score more than 2.5 and start studying, you are starting with a stress. I want to get 3A, 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 3A. With the stress when you study, remember, you don't do that with love. You do because it's a stress. Like that you are doing something because of fear. Because of fear only you are studying. Then it's not effective. Now that film, I watched that Vijay's film Nanban. If you have watched, they are telling a nice story there. They are telling in that film, don't go behind the victory. In the film, at the end, that film they are telling that, please don't go behind the victory. Grow yourself, improve yourself, then victory comes behind you. Same story. Don't fix a target like 2.4 Z score. Don't fix a target like that. What you do, you improve yourself more and more. Yesterday, your level was 30 marks. Today, your level is 31, 31, 31. Next day, 32. Likewise, day by day, improve yourself as much as you can. How much you can. Don't waste your time. When your other friends enjoying going for the relation's house and going for the parties, going for watching movies, when others playing games or when others spending times in TikTok, Insta, whatever, you tell yourself, no, I'm going for a plan. I'm going for 3A plan. I'm going for 3A plan. I can't do that. I don't have time. I'm putting everything. I'm putting everything in my end for studies. Every time, every second studies. Keep on focusing your studies day by day. Improve it. Every day you don't get in your life. Remember in life, even what is your level. You are going to get IELTS first. Also remember your development with the time graph going not to going to be like this. You don't see that I'm consistent studying, sir. I am not wasting time. So now comparing it yesterday, today my marks is good. Tomorrow more marks. Tomorrow more marks. More marks. It never happens. When you do the paper class and you realize that fluctuating. Sometimes comparing the last week, you improve it better. Marks also good. Suddenly you drop down. Then you improve a little bit, again drop down. You are improving bit, it will drop down. Drop down. Sometimes directly you are going down. If you are sick and if you could not come for classes, then your growth and if you don't keep in touch with the subjects, you grow, you drop like this. Again you are again you are with the time. We have 2 years. You have now for you. We have 1.5 years roughly. Then again growing. Right? Sometimes growing again drop, again growing, again drop, again growing. Likewise, till your A level life, this is how your life is fluctuating. The studies and all, your marks and all is fluctuating like this. If you notice, there's a sudden drop term test marks. If your paper class marks, your marks is 15 marks out of 100. Others are scoring 50, 60, and 50. If you once you drop down, if you don't start to work and if you just give up, then tata. Then you better you not to do A levels. Better you not to do A levels, right? Even how much you fall down, no matter how much you fall down, you should tell yourself, wipe your tear and all, and tell yourself, no, I have decided to go this journey. It doesn't matter what happened to me. I will go. I will go and again stand up, again start walking forward. You want to keep on moving forward. Every barrier you will face in this period, every barrier you fall down, somehow it's okay, wipe your tears and again stand, again keep on working, keep on going forward. That's a story. Story. Because 1 minute I talk this 1 minute, okay? Because in my O levels, in my A levels, in my class, I told the stories. There were 49 Is. All my students, all my friends got 9 Is in the Royal College. What happened was, I also got 9 Is. I also got 9 Is, and I also thought that my A level first term test going to be not difficult for me because I am the bright one. I got 9 Is, and for me, first term test is not a big story. Anyhow, I will lead the class, and I had a kind of what, kind of what thing like that. Then what happened? The first term test marks came, and my marks combined maths. I think I got 7 or 10 marks, and physics I think I got 50 something. Chemistry also 40, 30 something. I can't remember. What happened was because I got 9 is in my all history, I never scored lesser than 80, 85. Suddenly scoring a subject 7, 10 marks when you track the previous records, I never scored less than 80 something. The very first, not only me, because others also 9 is in their all levels life, same story. Suddenly getting 7 marks, 10 marks, 30 marks, 40 marks for subjects. What happened to others? For me also, they fed up. They went down. The confidence level and all fall down to this level, from sky to the ground. Then what happened? They didn't race. They didn't stand. They didn't overcome from that shock. Then what happened to most of them? They gave up. Then what happened? The results were S, C, W's. Me, I also fell down. Seriously, first term marks really made me fully fed up. I went down. That much I felt very upset because my life is fully biased to studies. I didn't do that much of sports also in my time. I didn't go to the other clubs and all also because my life is fully dedicated to studies. Suddenly, getting a marks like that really made me feel lots of things in my mind. I very fully stressed and sometimes I also very sad. Can't cry in front of parents also. I'm a boy. If you're a girl, okay, fine. Even you cry also is very normal. I can't cry also. But somehow I told to myself, no one there to tell me, support me also. I told me, it's okay, you keep on working, keep on working, keep on working, keep on working, work done. I can okay. Likewise, okay, don't worry, study. When you come for a class, stay focused and study. Study, don't waste your time. That's it. Nothing beyond that. 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 That story. Okay. Then, okay, right. Okay. Then story. Okay, we are very now 1.5 hours when we talk a little bit. It's okay. Right, okay. It's okay. Okay. Right. Okay. Then it's a now look here. Then we'll mark in the diagrams. Look here. I ask a question. When the light ray enters from rare to denser, raise your hands, how many we say? Raise your hands, how many we say? Incident angle is greater than refracted angle answer. If the light ray enters from rare to denser, incident angle is greater than refracted angle answer. Very clearly, I is larger. This is larger, R is smaller. Remember, I is larger, R is smaller. Right on here, somewhere is right on here. Incident angle is larger than refracted angle. Next story, tell me the relationship between I, R, and D. I, R, and D. See, look here. Incident angle is I. What is the vertical opposite angle of this I? The vertical opposite angle of this I is, see, the I is in between this normal and this incident path. I is between the normal and incident path. What is the vertical opposite of this I? Normal and incident path. That means, remember, I means R plus D. Am I correct? Important story. Incident angle is equal to, see, R plus D. Incident angle is equal to R plus D. Then from that, if they ask you in the exam, angle of deviation, that is equal to what? I minus R. I minus R. Important story. I minus R, you mark it. Important story. Important story. Right. Okay. So then here, in here, density area, remember, see, when you compare with incident angle, your R is greater. So we can say that in here, R is larger than I. That means I is smaller. I is smaller, R is larger. What is the relationship between I, R, and simple D? I, R, and simple D. Look here. If I ask you, what is this angle? This angle? Sir, here to here it's R. This angle is simple D. This angle is simple D. See? This angle is simple D. This angle is simple D. Enter one is R. This angle must be R minus D. This angle is R minus D. Am I correct? This angle is R minus D. This angle is R minus D. Okay, R minus D. Now, what can you say about this R minus Dn? This R minus Dn, this I. R minus Dn I. This In, R minus D, they are vertical opposite angles. Correct me? Look here, the normal line, incident path, I is equal to R minus D. I hope you understand. So you can say that I is equal to R minus D. That's also important. We subject R, so subject D. We subject simple D. Simple D going to be R minus I. Simple D going to be R minus I. These stories remember. These stories remember. Remember, rarer denser, I is larger. Denser rarer, R is larger. Story. Story. These stories remember. Remember, right there. Finish writing answer. Finish writing answer. Once finish writing answer. Finish writing answer. Okay. So then this space you should draw this diagram and these stories. This space you should write these stories. Okay. Then okay. Now that story also done. Story also done. We'll talk about absolute refractive index and we'll do that MCQ set and we'll take the break. Okay. 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 Right. Okay. Okay. R minus D. Right. Okay. So then next story. Next story is now we are talking about refractive index. We are talking about refractive index. So what is refractive index and especially refractive index? We are talking about two types of refractive index. One is absolute refractive index. Normally absolute refractive index only we talk as refractive index. Other one is relative refractive index. I will tell you what is refractive index is all. Remember, refractive index, we are talking about absolute refractive index and relative refractive index. I raise the board. Next story. Next story. Then we can do the MCQs and step by step we do questions also. This is very interesting subject. Stay focused. Stay focused. Study well. Okay. Right. Refractive index. This idea. There are two categories. Refractive index. Refractive index. One is absolute refractive index. Other one is relative refractive index. Absolute. Refractive index. Refractive index RI. Next one is relative refractive index. Relative refractive index. Normally, remember, absolute refractive index only we commonly call as refractive index. So in a question, if they mention refractive index of water is this much, they are talking about absolute refractive index. This is what we call as normally refractive index. If they are going to tell something about relative refractive index, they tell relative refractive index. Refractive index. Refractive index. Okay. First of all, we'll talk about what is this absolute refractive index. Now read it. Absolute refractive index is of a medium is a measure of how much the speed of light is reduced. How much the speed of the light is reduced when compared to its speed in vacuum. When compared to its speed in vacuum. Right. Now then, sir, then we understood that the conclusions from the story that you learned. Conclusion. Sir, we know that if the density of the medium is lower, more the medium becomes lower density, we know that speed of the light is larger. When you compare with glass, water density is lower, speed of light in water is larger. When you compare water with the air density is lower, speed of light is larger in air. Then when you compare air with a vacuum means no medium. Vacuum means in the vacuum region there is no any particles. Remember, in vacuum, speed of the light is maximum. Then tell me, what is the speed of the light? If you know this value, what is the speed of the light rays? If not, what is the speed of any electromagnetic waves, especially light rays, in vacuum? You guys know. Remember, the speed of the light is maximum in vacuum. The speed of the light is maximum in vacuum. That speed of light is equal to 3 into 10 to the power 8 ms minus 1. How many of you learned that story? Speed of light in vacuum is 3 into 10 to the power 8 ms minus 1 answer. How many of you learned that story before? You guys learned, right? Remember, normally when you consider any medium, vacuum has the largest speed of light. This is important. Vacuum spellings, I don't know. Right? So when you compare other mediums, speed of the light is less. Yeah, but remember, normally we consider when we are doing the story, speed of light in vacuum and speed of light in air, they are pretty much similar. But actual scenario, when you compare air and vacuum has the largest speed of light. But when we do the questions, we assume that even it's air or vacuum, both are similar mediums, and we consider speed of light in vacuum and air are same. Therefore, that is that's approximately something. And when you compare any other mediums, air and mostly they are giving water and they are giving the glass. The story. So then we understood medium to medium, speed is different. What is refractive index? Now we have defined a new physical concept. What is refractive index? Basically, we are measuring what exactly is refractive index. Remember, relative to the vacuum. when the light ray enters to a medium, maybe water, maybe air, maybe glass, relative to a vacuum, when the light rays enter into a medium, how much speed is reduced? How much speed is reduced? Kind of a measure as a fraction. Relative to vacuum, how much medium, when relative to vacuum, when the light rays enter into that medium, how much speed of the light rays reduced is measuring by refractive index. Is measuring by absolute refractive index relative to vacuum medium. When the light ray enters to this particular medium, how much its speed is reduced, that is going to measure by the refractive index. Refractive index. Okay, refractive index. Okay, right. Look here, we'll do the story and we'll finish the story. We'll take the break. Okay, stay focused. Only 9:43. 9:43. Stay focused. Stay focused. Stay focused. Right. Stay focused. Stay focused. Stay focused. Right. Stay focused. Okay. Okay. Right. Okay. Look here. Look here. Right. The story. Sometimes whatever I write in the word, if you feel important, write down. Absolute. Absolute refractive index. Absolute refractive index story. Index. Right here. Let's say now there's a light ray. That light ray is initially propagating in vacuum medium. Vacuum. Then the speed is, let's say, c. Then the frequency of the light ray is f. Let's say corresponding wavelength going to be lambda. Lambda. Suddenly, that light ray enters. Suddenly, that light ray enters to a certain medium. It can be water or glass or whatever. The light ray enters to a medium suddenly. The light ray enters to a medium suddenly. Okay. Then we know that due to a refraction, frequency doesn't change same as f, but we know that speed of that light ray in that medium is different. Now speed is, let's say c dash o whatever, certain medium. Is vacuum, right? Okay, right. Okay. Then speed is different. I say the now speed is c dash something, then corresponding wavelength will be changing. We know these stories. Wavelength will be lambda dash. Remember, absolute refractive index means okay, right? So now I ask a question. We know that speed is maximum in vacuum. Relative to vacuum, if you compare any medium with the vacuum, just compare any medium with the vacuum is going to be the rarer medium. Why? When you compare with any medium, vacuum has the largest speed of light. Then vacuum is always the rarer medium. Other mediums are going to be denser. Agree me? Even vacuum and water, vacuum and glass, definitely vacuum is the rarer, other medium going to be denser. Then let's say there's a light ray entering from vacuum to a certain medium. Vacuum to a certain medium. Vacuum to a certain medium. It undergoes refraction from rarer to denser, bending towards normal. Bending towards normal. Story we know. Story we know. The story we know. The story we know. Bending towards normal. Rarer denser. Vacuum to any medium towards normal. Okay. Right. Vacuum, any medium. Vacuum, any medium. Medium. So, absolute refractive index means what? Remember, absolute refractive index equals to, important equation, absolute refractive index equal to absolute refractive index. Refractive index equals to speed of the light in the vacuum over the equation. Speed of light in the vacuum over speed of light in vacuum. Light in vacuum over speed of light in the certain medium. Speed of light in that certain medium. In that certain medium. Certain medium. Medium is the equation. I know the story. So what you do now in this given space, here this equation, right? This space, the large space, absolute refractive index of a certain medium means speed of light in the vacuum over speed of light in that certain medium. I have the story. Highlight. The story highlight. Highlight. So if you go with a symbolic method, remember absolute refractive index symbol is, look here, it's somewhat different. This story is a bit different. This story is a bit different. Look here. I want to find the refractive index of a certain medium. Then look here, the symbolic method, refractive index of this medium capital M. I can see refractive index of the medium capital M relative to vacuum. Relative to vacuum. Relative to vacuum, normally we write vacuum somewhere here. Refractive index of a certain medium relative to vacuum. This is one way of representing absolute refractive index of this medium. If not, we can use another symbol. Look here. Sometimes what we do, we can write down absolute refractive index of a certain medium. Absolute refractive index of a certain medium, what we can do here, simple in the medium capital M, absolute refractive index of certain medium capital M relative to vacuum. We can write V somewhere here. But normally we are not using these two symbols. What we are mainly using is, look here, if it is always relative to vacuum, if you are finding the absolute refractive index, you don't want to specify relative to vacuum. You don't want to specify relative to vacuum. Only just mention refractive index of that medium, refractive index of water, refractive index of glass. Then we know if you just mention refractive index of water, refractive index of glass, then we know you are talking about relative to vacuum only. We know that. We know that. Therefore, mostly we are using the equation. Use a symbol is refractive index of the certain medium capital M. This is equal to speed of the light. This is equal to speed of the light in vacuum over speed of the light in that certain medium. CM. Right? This is the important story. You can highlight this entire story. This is important. Highlight story. Highlight entire story. Nice story. Nice story. Highlight. Nice story. Highlight. Still, I'm talking about absolute refractive index relative to vacuum speed. What is the speed in that certain medium? Highlight. Have doubt, ask. If you have doubt, ask. In that next page, this diagram also. Then you have doubts. So in the picture given, one has V and other has C. Now that's why now what you do now, mark that V as C dash. Here is C dash, lambda dash. C means, remember, speed of the vacuum. Right. Okay. Now quickly do this test 1, test 2, test 3. We'll come to this space. Important, I will give the 2 important points. Quickly find these 3 answers. Test me. Page number 7. Test me. Question number 2, 3, 4. I will give you a time. Time is 9:52. I will give 5 minutes. 5 minutes more than enough. I'll give 6 minutes. 9:52. Finish at 9:58. For one question, 2 minutes. More than enough. Start doing that. I'm going to start doing hands up. Start doing hands up. Test me. Start doing hands up. Start doing test me. Hands up. Hands up. Hands up. Start doing test me. Hands up. Okay, do it. Finish at 9:58. Simple, huh? Simple. Very simple. Start doing. Start doing. So which part should we write in the 2 boxes? And that larger box, this part, and the smaller box, this part. Remember, absolute refractive index means, remember, again, somewhere else write on same story. Mainly we are using this equation. Absolute refractive index means COC. Find the test me. Start doing test me. Start doing test me. Start doing test me. Start doing test me. Then anyhow we'll do that MCQ questions also, and we are going to the break and we are going back to next story. COCM. 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 Every point is explaining properly. Every point is explaining properly. I give the exam past discussion also I am doing. See, last day we effectively how around 3 hours we discussed fluid dynamics MCQs. I think beyond that they can't ask questions because I am doing everything. Right? You don't have any single point, sir. I don't understand the story. Sir, I'm not sure about this. I don't understand this theory point. Because I'm explaining theory class, taking time and explaining theories, past paper class, doing all the past paper, MC, everything. And then now paper class also started. Day by day work is increasing for your batch. This is my proper online batch also. Want to do this batch also properly. Without inner stress. That's my target. 27, I will work more. Sir, no tute, sir. I send your tutes. You will get only next week. Therefore, only tolerate. I will temporarily what you do, whatever I write in the board, you just copy. Whatever I write in the board, you will copy, and I will ask from you. You can ask from any student. It can be Amaya, it can be Akshata, Kanishka, Zoha, Afnato, anyone. You can ask and you can take their numbers. If not, you can put in the group also. Then they will help you. Ask them. Can you please share that last week theory note because I want to write down. If you ask, they will send. If not, you ask me, then I will ask them and I will send you also. Okay. If you finish doing those question number 2, 3, 4, hands up. 9:58 ni. Finish hands up. Finish hands up. Basic substitution. Finish hands up. Finish hands up. Finish hands up. Finished. The most important thing is next story. Next story that there are 4 MCQs. Let's see. Okay. Right. Don't do that's the MCQ stories. Okay, right. 3 finished. 3 finished. I will give 1 more minute. I'll give 1 more minute. Not difficult. It's not difficult. It's not difficult. And tell me, you are okay of doing this tute, co-tute, and writing the tutes and stories. You're okay or not? Tell me. If not, we can write in the book also. Not. It's up to you. It's up to you. I try maximum to keep your attention in the class, and I try maximum to spend the class effectively. Normal other theory classes, you get bit sleepy also. Genuinely, okay, I'll ask a question. Serious question. Genuinely, hands up. No, I don't know. I can't come and see you. You are home. Genuinely, hands up. In my class, when I'm doing a class, you feel sleepy, hands up. Anyone? Genuinely. Hands up who are feeling sleepy, hands up. Not sleepy, genuinely. Not sleepy. Not sleepy. That's the important thing, okay? How many of you lied? Hands up, how many of you lied that? Sir, how many of you lied genuinely? Sir, I lied you. Actually, in your class, I feel sleepy, but not to say in public. That's why I said that not sleepy. Hands up, who lied? Hands up. No one lied. Then okay. Then okay. Then okay. What do we need to write under important points? I will tell you. I will give you the point. Don't worry. I will discuss. Test me. Test me. Then questions. Question number 2. Question number 2. Simple time is enough. Hands up. Finished. Hands up. If you finished, raise your hand. Don't raise down. If you finish writing, raise your hands. Until I raise down, you don't raise down. You just stay. Raise your hands. Raise your hands. Many finished. All of you finished. Don't raise down. Then 6 people finished. 6 people finished. Right. I'm doing. Velocity of light in the glass is 2 into the power 8 ms minus 1. Find the absolute refractive index of the glass. So I want to find the equation to find the absolute refractive index is, you know, that you told us, that is in that relevant medium equals speed of the light in the vacuum over speed of the light in the relevant medium, capital M. If I want to find the absolute refractive index of glass, so I want to find the absolute refractive index of the glass. That means absolute refractive index of glass is Ng, right? Ng must be equal to speed of light in vacuum. Speed of light in vacuum. They have given, right. And now you have no idea about what is the speed of light in vacuum. Ni? That's the problem. Okay. Important point, write down. First important point. Important point. Write down. First important, write down. The speed of light in vacuum. Write down. Other important points, write down. The speed of light in vacuum. You know this value. The speed of light in vacuum is 3 into 10 to the power 8 ms minus 1. The speed of light in vacuum is 3 into 10 to the power 8 ms minus 1. The speed of light in vacuum is 3 into 10 to the power 8 ms minus 1. ms minus 1. Highlight this value. Speed of light in vacuum. Any light ray, any electromagnetic wave, 3 into the power 8 ms minus 1. If I ask a question, do you think this refractive index, do you think this absolute refractive index have units or dimensions? Do you think absolute refractive index have units or dimensions? Speed of the light ray in vacuum, unit is ms minus 1. Speed of light in the medium is also ms minus 1. They get cancelled out. Then we know that. Remember, absolute refractive index does not have units or dimensions. Write down red color pen. Important point 2. Absolute refractive index does not have any units or dimensions. Absolute refractive index does not have any units or dimensions. Red color pen. Absolute refractive index does not have any units or dimensions. Then we know. Question number 2. Speed of light in vacuum is 3 into 10 to the power 8. 3 into 10 to the power 8. Over in that medium, in the glass, speed of light given how much? That is 2 into 10 to the power 8. The glass given 2 into 10 to the power 8. So then the answer will be, we all know that 3 over 2. Normally we don't keep as 1.5. We keep in fraction format 3 over 2. Absolute refractive index of glass is 3 over 2. Likewise, then question number 3, they're asking us to find the velocity of light in water is this much. Absolute refractive index of water. If I want to find the absolute refractive index of water, same story. Absolute refractive index of water means speed of light in vacuum over speed of light in water. Speed of light in vacuum is how much? 3 into 10 to the power 8 over speed of light in water. They have given 2.25 into the power 8. 2.25 into 10 to the power 8. Then we can get the answer 3 over 2.25. 3 over 2.25 means, look here, 3 over 2.25 means, see what I'm doing. 3 over 2.25 means, if you multiply numerator and denominator by 100, you multiply them by 100. You multiply them by 100. If not, right. Okay. I multiply up and down by 100. 100. So then you are getting how much? You are getting 300 over 225. 300 over 225. Now divide up and down by 75. We divide by 75. There are 4 75s for 300. There are 3 75s for 225. Finally, remember, absolute refractive index of water is 4 over 3. Absolute refractive index of water is 4 over 3. It's going to be 4 over 3. The next story, question number 2, 3 done, and fourth one. Fourth one, then they are asking. 3 done, then fourth one. Fourth one, you have to find the absolute refractive index of AR in vacuum. AR or vacuum. Normally, I told you, normally AR and vacuum, we consider they are similar. So they are asking AR/vacuum. Please mention what is the absolute refractive index of AR/vacuum. Fourth one. Again, if you want to find the absolute refractive index of AR/vacuum, AR or vacuum. If you want to find the absolute refractive index of AR or absolute refractive index of vacuum, the definition, speed of light in vacuum is 3 into the power 8. 3 into the power 8 over speed of light in the relevant medium. If I want to find the speed of light in air, if I want to find the speed of light in vacuum, same as 3 into 10 to the power 8, resulting 1. Resulting 1. Right? This stories. This story. This story. Right. Okay. Then somewhere else write down. Somewhere else write down in that given space. Write down. In questions. In questions. We consider vacuum and air have similar properties. In questions, we consider vacuum and air have similar properties. Vacuum and air have similar properties. Vacuum and air have similar properties. Full stop. Therefore, speed of light in air also equal to, therefore, speed in light in air also equal to, therefore, speed in light in air also equal to 3 into 10 to the power 8 ms minus 1. 3 into 10 to the power 8 ms minus 1. It's totally any. Right. Right. Okay. Right. So what is the absolute refractive index of vacuum? 1. What is the absolute refractive index of air? 1. What is the absolute refractive index of water? 4 over 3. What is the absolute refractive index of glass? 3 over 2. You must learn by heart these values. You must learn by these values. Remember, right? This story. Highlight, remember, air, absolute refractive index 1. Water 4 over 3. Glass 3 over 2. Remember. Then you solve a kind of inequality between absolute refractive index of air, glass, and water. What do you notice? Look at similarity. The similarity we noticed here. We noticed here. We noticed here. We noticed here. We'll take the break, okay? We'll do the question. We'll do the break. We noticed here. So you told us when you compare air, speed of air and speed of vacuum, they are same, largest. Then water and glass. Okay, water and glass speeds. Glass is the denser medium, the most denser medium. Glass has the lower speed. So if I just find the absolute refractive indexes, I noticed absolute refractive index is minimum in air. That is 1. Other values are more than 1. Remember, the first thing is any medium that you see in the questions, their refractive index must be more than 1. It's impossible to have a medium having refractive index less than 1. Even the vacuum is having refractive index 1. How it's possible to have a medium having refractive index less than 1? That story is keep in your mind. Then the important story is absolute refractive index of ARO, vacuum is lesser, right? Then absolute refractive index of water is a bit larger. 403 means 1.33. 302 means 1.5. Largest glass. So now you just put some short mind maps. Larger the density, larger the absolute refractive index, smaller the velocity. Likewise, put some mind maps and write the story also somewhere else important. Somewhere else write the story also will be important when you are arguing. When you are doing MCQs, will be important. Up to now, everything is crystal clear and up. Everything we discussed up to now, crystal clear and up. Everything is solid clear, crystal clear and up. Everything is crystal clear and up. Crystal clear. Everything is crystal clear and up. Hands up. Crystal clear hands up. Crystal clear hands up. Hands up, hands up, hands up, hands up, hands up. Hands up. Crystal clear hands up. Crystal clear hands up. Hands up. Hands up. HENDS hands. UP up. Hands up. Right, okay. Now, almost 10:07. Won't take the break. Before that, I will give, let's see, we'll do a small MCQ. Take page number 8. Page number 8, there are, test me, there are question number 5, 6, 7, 8. Normally in your exam, they are giving 2 minutes, so maximum 3 minutes for one MCQ. So therefore, what you do, I'm giving exact time is 10:07. I'll give 10 minutes. I'm giving 10 minutes, more than enough 10 minutes. If I ask you to start, you're going to do it. 10 minutes. If I ask you to do, I ask you to start and do it. But don't you do now, right? Now time is, you should do those 4 MCQ within 10 minutes. Okay, now time is 10:08. Start doing those 4. Finish at 10:18. Start doing those 4. Start doing those 4. Finish at 10:18. Start doing 10:18. Finish 10:18. 10 minutes. Test me 10 minutes. Start doing. Test me. Think it is an exam. Think you are doing an exam. Do it. If you finished, hands up. 3 minutes. Five minutes is enough. It's okay, 10 minutes. These are exam questions, past paper questions. Anyhow, past paper class we'll discuss separately again. These are past paper questions. If you learn the theory properly, see how it's easy. Question number 8, statement C, take it as correct. You don't know statement C story, it's okay. Statement C, question number 8, statement C is correct. Argue remaining stories. If you finished, answer. 5 minutes finished. If you're in the right speed, you should finish by now. 5 minutes is enough. Then many in the right speed. Okay. But don't worry, your speed will be improved when we do the writing and all. How many finished? Then many finished. Time up. Then many finished. Therefore, time up. Time up. In 13, 5 minutes enough. Okay. Now we'll discuss those things and let's see. Then we'll take the break. Okay. Then that story. Will a light wave? Question number 5. Story. So we all know from the state that we learned right now. Just now we learned. I explained everything properly. Then a light ray traveling in a rarer medium to enter denser medium. Rarer denser. Its velocity increases wrong. Rarer denser. Speed is decreasing. Wrong. Option 2. Only the frequency of the wave changes. Wrong. Refraction frequency is constant. Only the wavelength of the wave change. Actually, during a refraction, wavelength as well as speed is changing. Refraction is mainly because the change in speed as it enters from one medium to other. Because speed changes and frequency remains constant only, wavelength changes. Explain properly. Only the wavelength of the wave changes. Wrong. Both velocity and wavelength changes correct. Both frequency and wavelength remain unchanged. Wrong. Answer is 4. Past paper MCQs. Your last few year past paper MCQs. How it's easy. Some MCQs. 5 done. 6. 5. Then 6. 6 1. Which one of the following summarizes the changes occur when visible light passes from air to glass? Visible light passes from air to glass. Air rarer, glass denser. Rarer, denser. You know, when the light ray is passing from rarer to denser, frequency constant. No change. Frequency no change. From there, you can tell the right answer should be option 1, option 5. Frequency is constant. Therefore, out of 5 options, you can remove option 2, option 3, option 4. Because when light ray enters from linear refraction, frequency doesn't change, it's a constant. Therefore, we can remove option 1, option 5. So we can remove option 2, 3, 4. Answer should be option 1, option 5. Then we know speed is changing. Then, but option 1, they are telling speed no change. Wrongly. Speed changes. Volume changes. Answer is 5. Question number 6, answer is 5. Simple story. Is this difficult? Past paper questions? Are this difficult? I know that if you are learning properly, in MCQs, out of 50, 30 you can score easily. If you learn the theory properly. 7.1. Consider the following statement made regarding the refraction of light. Statement A, refractive index of a medium is equal to the industrial refractive index, that is the absolute refractive index. Refractive index of a medium is equal to the ratio of speed of light in vacuum speed, ratio of speed of light in vacuum over speed of light in that medium. Some small printing mistakes are there. Statement A is correct. Statement A is correct. Question number 7, statement A is correct. Statement A, statement B, statement C. You know statement A is correct. Statement B. Statement B, what they are telling? Statement B, they are telling, B, they are telling, B. Then as light travels from one medium to another, its frequency does not change. Correctly? Light travels from one medium to another, frequency does not change. Correct. Statement B also correct. Statement C. C statement. C statement. You put right and wrong. If your answer is wrong, put wrong and mark the right answer. Next statement C. The wavelength of the light reduced when it is passes from vacuum to medium. We know that when the light ray is passing from vacuum to the medium, when light ray passes from vacuum to the medium, what happened to the speed? Speed of light is maximum in vacuum. Speed of light in that medium is lesser. Anyways, when light ray passes from vacuum to that medium, speed is lesser. Speed is lesser. According to V equals F lambda equation, we know that V equals F lambda equation, we know that frequency is constant. When your speed is decreasing, your wavelength also decreasing. Lambda decreasing, therefore statement C also correct. They are telling what? Statement C, they are telling the wavelength of light is reduced when it passes from vacuum to medium. Correct. Statement C also correct. Reduced. Nice story. Nice story. Therefore, A, B, C all correct. Right answer is option 5. All A, B, C answer is 5. The next one, you can't argue the statement C. That's why I said statement C is correct. But you can argue statement A, B, C. Statement A, statement B, statement C. Statement A. Refractive indices for the red light and blue light in crown glass is 1.51, 1.52 respectively. Consider the following statements. I will tell you red and blue stories, red, blue, violet stories, everything I will teach you, don't worry. But you can get it based on the theory that you learn now, you can do this question. Red light have small refractive index 1.51, but blue has a large refractive index 1.53. Consider the following statements. A, the speed of light and blue, the speed of red light and blue light in vacuum are same. I said any light ray, anything in the vacuum, their speed is going to be the 3 into the power 8 ms minus 1. Statement is correct. Statement is correct. Statement B. B what they are saying? In B they are telling, B they are telling, the speed of red light is greater than the blue light in glass. The speed of red light greater than speed of blue light. I told you, larger the refractive index. Somewhere else, write down if you want in that somewhere else. Remember, larger the refractive index, right, Missy? Glass has the large refractive index, small the speed. Somewhere else, write down large refractive index, small the speed. Somewhere else, write down. Please write down the stories. Don't you think you can remember this? No. Somewhere else, write down large refractive index, small the speed. We know that red and blue, red's refractive index 1.51, blue 1.53, larger refractive index is smaller speed, red has the small refractive index, red has the larger speed. Then speed of red light is greater than the blue light. Red's refractive index smaller, that means red has the larger speed. Statement B is correct. C is correct. All ABC. Hands up, how many of you got out of 4 these MCQs? Answer is fine. Out of 4 MCQs, raise your hands. How many of you got 4 out of 4 hands? 4 out of 4 hands, genuinely. 4 out of 4 hands. Within 5 minutes, you tried 4 MCQs. 4 out of 4, genuinely, yeah? 4 out of 4. 3 out of 4 hands up. 3 out of 4. 3 out of 4. 3 out of 4. 2 out of 4, genuinely. Doesn't matter your marks. 2 out of 4. Right. 1 out of 4. Okay. Fine. Look here. See. See. Even just now we learned the theory. Just now we learned the theory. We have done very kind of basic past paper questions. Past paper questions only. Sometimes we can wrong. Even the question is not difficult. But see, but still we can wrong some MCQs. So therefore, see, you got it right? So therefore, don't make these types of mistakes in your L exam paper. Nothing difficult. I taught everything right now. I taught you. So therefore, don't keep any mistakes. Upcoming days we'll do like this also. Right. Up now session is very effective answer. Time to take a break. Up now session is very effective answer. It's very effective. Up now session is very effective answer. Very, very effective. Okay. Right. Now the time is 10:21. Now don't worry. I will put extra classes and I will finish the syllabus properly. Right. But won't finish properly. There is a way. Now my teacher style is like this. I want to teach you every point properly. If I don't teach, I can teach. Just come to my revision class. So you will come anyways. When I do the revision class, then you see how the way I'm teaching. Not like Baba part telling every point. No. Only important things telling there. This theory class means theory. Every point must be explained properly. Okay. Time is 10:22. We'll take a 50-minute break. We'll take a 50-minute break. 10:22, 10:32, 10:37. 10:37, not 10:38. 10:37, no? 10:38. Eat something, drink something. 10:38. Yes. At what time break finishes? I told you at what time you guys to come back. At what time I told you guys to come back? At what time I told? 10:38. 1 minute ago. Right, okay. Hey guys, right. Next story. Next stories are there. Okay. So then enter into good stories. Okay. Right. Okay. 10:37. 10:37. Always talk with me and tell your problems and issues. In my side, if I can give you solutions, I will give you definitely. 10:30. Break is finished. Okay. Hands up over the breakfast in the time, hands up. Over the breakfast in the time, hands up. At the breakfast in that 15 minutes, hands up. Yes, me too. Stomach is now filled. Okay. Right, okay. Okay. Right, okay. Next story. Absolute refractive index is very simple. Relative to the vacuum, the speed of the air. Sorry, relative to the vacuum, the speed of certain medium. What is the absolute refractive index? The idea? Absolute refractive index means that is a kind of measure to find that how much amount that the speed of the light reduced when enter into a certain medium. If the light rays enter into a certain medium, how much the speed is reducing. To measure that only, we are defining a physical quantity that is refractive index. Absolute refractive index means always relative to vacuum. As it light ray enters to a certain medium, the reduced velocity, the reduced speed is a measure. When you come to the relative refractive index, relative to any one type of medium, what would be the reduction in the speed in other medium? That story. Don't worry, I will tell you. Write down next story. Then next story. Next story. Right. Okay. Right. Next story, write down. That refractive index, sorry, relative refractive index, next site. Next side, page number 9. The first point, the refractive index is a measure of how much light bends. The refractive index is a measure of how much light bends when it passes from one medium to another. It should be the relative refractive index. It should be relative refractive index. Write down the relative refractive index, a measure of how much light bends, refracts when it passes from one medium to another. Okay, same story. Now here we can write two equations again. Right. Okay. This story. Right. Look here. Look here. Relative refractive index. Where is my black pen? Okay. The next story. The next story. Relative refractive index. Relative refractive index. Next story. Stay focused. Time is almost 10:40. You're going to stay with me for 1 hour and 40 minutes. 1 hour and 20 minutes. Last 1 hour. Relative refractive index. Index. This idea. It's a new lesson. Optics. Don't you miss any point. Please ask some doubts. Ask whatever that you have. Right. So this story, similar to absolute refractive index. In absolute refractive index, always you are measuring the reduction of speed of a certain medium relative to the vacuum. If it is relative refractive index, you are comparing any two mediums, not always vacuum. You are comparing any two mediums and you are going to measure how much speed of the light ray reduces as it enters from this medium, that medium. That is the idea. Speed reduces means the bending. Bending is also different because remember, when the speed changes means the amount of light ray bends in the other medium also changes. When the speed different, amount of light ray bends in the other medium also different. This story, look here. This story. This story. Look here. Right. Then look here. Right. Okay. I consider medium two mediums. One is medium one, other one is medium two. Common interface. And this is the normal. And this is my medium one. Medium one. This is my medium two. And incident ray, incident light ray, incident light ray. And normal common interface, incident point is so refracted light ray. Yes, right. Okay. Speed of the light incident ray in medium one, I mark it as C1. Speed of the light in medium one is C1. Right? So speed of the light in medium two is C2. C2. Now, I'm going to find the refractive index of medium 2 relative to medium 1. If I now let's say now they're asking the question relative to medium 1, what is the refractive index of medium 2? Look here. If medium 1 is just think medium 1 as air, when you consider medium 1 as air, for an example, just think medium 2 as water. So we all know that absolute refractive index of air. We all know absolute refractive index of water relative to vacuum. The speed reduction in air, this story we know. Absolute refractive index we know. We know absolute refractive index of air, we know. Absolute refractive index of water, we know. Relative refractive index means the story is when light ray is traveling from one medium to another medium, maybe air to water. If you want to check how much speed is deviating, if you want to check how much this light ray is going to bend, that is what we call as relative refractive index. Let's say you want to find the relative refractive index of medium 2 relative to medium 1. See, refractive index of, not difficult, refractive index of medium 2 relative to medium 1. Let's look at the story. Refractive index of medium 2 relative to medium 1. Relative to medium 1. How can I the equation? Relative to medium 1. Relative to medium 1. That is equal to what? See the equation. The space is not enough. See the equation. The referring medium, the relative to what medium? Relative to medium 1. Absolute refractive index means what? Absolute refractive index of a certain medium means what? Relative to vacuum medium, the reduction in the speed in the certain medium. Absolute refractive index means speed of the light in vacuum over speed of light in that certain medium. Then from this we can derive that equation. Refractive index of medium 2 relative to medium 1. Here C means relative to vacuum speed. Here C means relative to vacuum, C means speed of vacuum. Now here relative to medium 1. Relative to medium 1 means here you will write on the denominator what? Speed of the light in medium 1. Am I correct? You are relating relative to medium 1. So therefore here you should write down speed of light in medium 1. You can write down speed of light in medium 1. You can write down speed of light in medium 1. Right? Speed of light in medium 1. Okay, speed of light in medium 1. If not velocity of light in medium 1. Speed of velocity up to you. Speed of velocity. Velocity of light in medium 1. In medium 1 over velocity of light in medium 1. No space. Medium 1 over absolute refractive index of a medium means speed of light in vacuum over speed of the light in that medium. Refractive index of medium 2 relative to medium 1. Then denominator must be speed of light in medium 2. Speed of light in medium 2. Velocity of light in medium 2. Answer this equation, clear answer. Velocity of light. This equation, clear answer. Medium 2. Medium 2. Medium 2. Right. Medium 2. Highlight. Now there are two boxes. Now in this box, write this, and here we are at the symbols. So now look here, the symbol. Now I want to find the refractive index of which medium? I want to find the refractive index of medium 2. Remember, the medium where you're going to find the refractive index. Now medium 2, you are going to find the refractive index of medium 2. Medium 2. 2 must come here. 2 must come here. 2 must be here. Relative to what medium? Relative to medium 1. Medium 1. Same story there. Same story. Absolute refractive index of medium relative to vacuum. Same story. So when you read this, you want to tell that refractive index of medium 2 relative to medium 1. First of all, you should read this. Then only you want to read this one. Refractive index of medium 2 relative to medium 1. If not, you can tell the other way also. Refractive index of medium to see. Refractive index of medium 2 relative to medium 1 must be equal to, now you know, equals to what? Now equals to speed of light in medium 1, C1 over C2. C1 over C2. C1 over C2. Nice equation. Very simple. See, refractive index of medium 2 relative to medium 1. See, what is at the top? 1 is at the top. 1 is at the bottom, 2 is at the bottom. Then 1, 2. And refractive index of medium relative to medium 1. 1 is in the top, C1, 1. 2 is at the bottom, 2. Think like that. Then you can remember. This story highlight. Highlight. In the first 2 boxes. I have given other 2 boxes also. Large one and smaller one. In the large and smaller one, next story is, sir, when you find the refractive index of medium 2 relative to medium 1, I understood. So what if I want to find the refractive index of medium 1 relative to medium 2? If I want to find the refractive index of medium 1 relative to medium 2, in that case, I erase here. So if I want to find the refractive index of medium 1 relative to medium 2, then you can write down, see, refractive index of refractive index of medium 1 relative to medium 2 of medium 1 relative to medium 2 relative to medium 2 medium 2 medium 2. Then you know the equation equals refractive index of medium 1 relative to medium 2. That means I will write down speed of velocity of light in medium 2. Velocity of light in medium 2. Write down velocity of light in medium 2. Velocity of light in medium 2 over Nice stories. Over velocity of light in medium 1. Velocity of light in medium 1. Over velocity of light in medium 1. Medium 1. Done. Done. The difficult part is this is the difficult part. That is also done. Symbolic method. Symbolic method. That's a pattern. See, refractive index of medium 1 relative to medium 2. Refractive index of medium 1 relative to medium 2 must be equal to what? Is 2, bottom is 1. Speed of light in medium 2 over speed of light in medium 1. Speed of light in medium 2 over speed of light in medium 1. That's it. Nice story. Now you can do that story also. If you write that story, right? Simple in refractive index of medium 1 relative to medium 2. Okay. By this. Right. Okay. Done. Done and dusted. Right. Finished hands up. Finished hands up. Finish hands up. Finished. Highlight the next two boxes, these two. And again, I will give some time. Question number, I'll give some time. Okay, start doing question number 9. Start doing 9. 9 is easy. 10, 11, 12, I'll guide you. If you can do 10, 11, 12, you keep on doing 10, 11, 12 also. Start doing 9, 10, 11, 12. Start doing. According to the absolute refractive index, always incident ray will be in vacuum. Yes. So need to write the equations. Write the equations, okay. Write the equation and start doing that. Test me question number 9. Start doing that quickly. Start doing that. Nice story. Now optics is a really good lesson. My favorite lesson in oscillation waves. Optics, my favorite. That doesn't mean your favorite. I like to teach optics. And then my favorite in oscillation waves is the Doppler effect. You will learn. It's a nice lesson. Doppler effect is a nice lesson. In mechanics, my favorite is hydrostatics, and fluid dynamics also I like. Hydrostatics is my favorite lesson. There are some exam points I want to teach you. Definitely I will teach. I will do an additional session. Don't worry. I will teach. Okay. Finished hands up. 9 finished. Sir, I finished 9th on hands up. 9th finished hands up. Sir, 9 finished. Then if you finish 9th one, do just 10, 11, 12, just do it. 10, 11, 12, just do it. You can just try doing 10, 11, 12. Nice stories. 13, 14. Keep on doing. 13, 14, keep on doing. Keep on doing that. Keep on doing. Do it. You guys keep on doing. I'm discussing one by one. Upcoming tudes, what I do, every theory, after discussing theory up to a certain level, rather than continuously, now we are doing questions also. After doing some bunch of theories, we'll just keep 5-minute test and we'll do some MCQs regarding came from those theory points. Then it's better, right? So then 5 minutes, let's check the marks and how much marks you got. Then you can evaluate me. So we'll do that session also. We'll try to improve it. And tell me your methods and tell me your opinions, what we can do to improve the class more and more effectively. You guys tell me that updates. I need your responses also. Don't make this thing the class as a very stressful class. No, stay whatever the way that you prefer and interestingly study. Study interestingly. Right. 9th one, velocity of light in glass is 2 into 10 to the power 8 ms minus 1. The velocity of light in water is 2.25 into 10 to the power 8 ms minus 1. Find, read that, find refractive index of glass relative to water. Find refractive index of glass relative to water. Question number 9. Find the refractive index of glass relative to water. How do you write down? Refractive index of glass relative to water. Must be equal to what? Top is water, speed of light in water over speed of light in glass. Substitution. Thereafter easy. Speed of light in water. That is how much? That is how much? Speed of light in water. Water is 2.25. 2.25. 2.25 into 10 to the power 8. Speed of light in glass is just 2. 2 into 10 to the power 8. So then you are getting that refractive index of glass relative to water. We are getting as how much? 2.25 over 2 means it's going to be 1.25. 1.25. Simple. 10 to the power 8, 10 to the power 8 cancel out. Then 2.25 over 2 means 1. My bad. 1.125. My bad. 1.125. 1.125. Right. That is done. Then 10th one. Hands up. Anyone finished 10th answer? Anyone finished 10th answer? Question number 10 finished. Anyone? One student finished. Question number 10 finished. 10th one finished. 2 finished. 2 finished. 10th one. 10th one. That is somewhat a different story. Different story. But nice question. 10th one. N1 given data. N1 is C over C1. N1 means C over C1. N2 means C over C2. N2 means what? C over C2 given data. What they're asking us to show that refractive index of medium 2 relative to medium 1. Refractive index of, we want to show that refractive index of medium 2 relative to medium 1 must be equal to N1 over N2. N1 over N2. N1 over N2. I think this is a small change must be there. Refractive index of medium 2 relative to medium 1. That must be there, telling us to show that right? It should be, I think, N2 to N1. He has made a mistake. It should be N2 to N1. Prove that refractive index of medium relative to medium 1. It should be N2 to N1. As per my understanding, it should be N2 to N1. I think it should be N2 to N1. We'll check this, sir. You want to show this. This is what you want to prove. From these two, you want to show this one. Right. Okay. Look very carefully. Listen very carefully. Listen very carefully. Listen very carefully. Now, different people can have different approaches. You can do this story in different manner. Doesn't matter. It's up to you. But anyhow, if you come to the answer, that's it. Now, see this idea. See this idea. Right. See this idea. I start from this left side. Then we know that refractive index of medium 2 relative to medium 1 means. So we learned refractive index of medium 2 relative to medium 1 means we learned, if you can remember, speed of light in medium 1. Top is 1. C1, speed of light in medium 1 over speed of light in medium 2. Right? Okay. So this is the definition, sir. This is the definition. C1 over C2. So now, if I ask you, N1 is C over C1. What is N1? N1 is absolute refractive index of medium 1. Why? C means speed of light in vacuum over C1 means speed of light in medium 1. So therefore, N1 means absolute refractive index of medium 1. N2 means absolute refractive index of medium 2. We learned story. So, sir, what can I do, sir? I take this as equation 1, sir. This is equation 1. And so this result, I take it as equation 2, sir. This is our equation 2. If not, let's say N1 means C over C1 is my equation 2. The given data N2 means I take it as C over C2, equation 3. So what can I do, sir, then? What can I do, sir? Shall I, in order to create this C1 to C2 ratio, C1 to C2 ratio, sir, I thought of dividing equation 3 by equation 2. I'm going to divide equation 3 by equation 2. If I do that, sir, I can write down equation 3 over 2 means n2 over n1 must be equal to n2 over n1 must be equal to C over C2 division. C over C2 division C over C1. We know all level maths. N2 to N1 must be equal to, sir, C over C2. Division becomes multiplication, reciprocal. Multiplication, sir, reciprocal, sir. Then C1 to C2. C1 to C2. C1 to C, sorry, C1 to C. Then here C cancel out, sir. I can write down N2 to N1 ratio must be equal to, sir, C1 over C2. I take this result as equation for something, right? So then shall we go back to the equation 1? C1 over C2. C1 over C2. I'm going to substitute. Instead of writing C1 over C2, I'm going to substitute N2 over N1. Therefore, finally, we can write down finally. So finally, I can write down. So finally, I can write down. So finally, we can write down. We can write down from equation 1 and from equation 1 and 4, we can write down, sir. Refractive index of medium 2 relative to medium 1 is going to be equal to what? C1 over C2. C1 over C2 means what? N2 over N1. Nice story. N2 over N1. Learn by heart. This result. Learn by heart. Very important. Highlight this. Remember, after writing this one in that given space may be not sufficient. After writing this, highlight this result. Now see, relative refractive index in the definition we wrote in terms of speed ratio, right? In refractive index of medium 1 means C1 over C2. But you can write down relative refractive index in terms of absolute refractive index ratio. N1 means absolute refractive index of medium 1. N2 means absolute refractive index of medium 2. Then you can write down, sir, relative refractive index of medium 2 relative to medium 1 is absolute refractive index of medium 2 over absolute refractive index of medium 1. Super highlight. Highlight story. Highlight, huh? Take box it. Also take your highlighter and highlight it. Highlight the story. This story is important. These are the theory things. I know from the very first attempt you can't do these things. These are theory things. Highlight. This is clear answer. This is clear answer. It's clear answer. It's clear. It's clear answer. Clear? It's clear. Right. Then question number 10 discuss 11, 12. 11, 12. 11 also you can learn something. 11. I think now you got the idea. Now you can find the 11th one. 1st one you can write the 11th one. 11th one. Refractive. So now they have given absolute refractive index of glass 3 over 2. Absolute refractive index of water 4 over 3. Show that WNG means they have given refractive index of glass relative to water equals 1 over refractive index of water relative to glass. So you want to show this, that question number 11. You can learn something from every question. Highlight this one, question number 11. So they are giving us to show that refractive index of glass relative to water always equal to refractive index of glass relative to water always equal to 1 over division. Only 1 division refractive index of water relative to glass. We have to show this. Let's show this. Let's show this. Let's show this. Sir, I'll start from this side, and if not, you can start from this side and you can come to here. It's up to you. It's up to you. You can start from here to here. It's up to you. What can we do? Right. What can I do now? Right. Okay, I'll start from this left side. If I start from left side, left hand side, I'm starting from left hand side, and I'm going to show that left hand side. I'm starting from left hand side. I'm going to do a simplification, and I'm going to show left hand side is right hand side. It's right hand side. It's right hand side. Left hand side, right hand side. Okay. Look at this story. left hand side. This is the right hand side. Take left hand side. Left hand side equals what? Equals refractive index of glass relative to water. Then we know the definition. So refractive index of the easiest one is going from right hand side. Easiest one is going from right hand side. Therefore, I go from right hand side and I'll show the left hand side. I start from right hand side. I finish left hand side. Okay, that is easy. So 1 over. So 1 over refractive index of water relative to glass. So you told the definition. In terms of speed, if I write this relative refractive index, so I want to find the refractive index of water related to glass. Top one is glass, right? Therefore, speed of glass over speed of bottom, speed of water. I taught you. So this is something like this. So this is something like one division, speed of glass over speed of water. Sir. So all we learned that one division is multiplication, reciprocal, sir. Reciprocal, sir. CW over CG, sir. CG, sir. Finally, I'm getting, sir, CW over CG. CW, CG means what, sir? Sir, we know top is water, bottom is glass. Top is water, bottom is glass. That means top is water, bottom is glass. Refractive index of glass related to water. Start from left side. Sorry, start from right hand side. Start from right hand side, right? And I did something, and ended with left hand side. Refractive index of glass related to water. Okay, therefore, right hand side, left hand side equal. Right hand side, sorry, this is left hand side. This is right hand side equals left hand side. Story. RHS, right hand side. RHS, RHS, RHS. Clear, right? Clear. But from this, we have to do lots of derivation stories. I will give from this. We want to summarize it and we want to put some important points also. This question also clear. 11 also done. You have experience. 11. Now quickly same story. 11 is same story. Quickly prove 12. Now 11 and 12 same. Hands up, proof, finish proving 12 hands up. Hands up, proof, finish proving 12 hands up. 11 and 12 same. 11 is same. Follow that. Hands up. Don't raise your hands down. Start doing 12. I'm not going to do 12. I am not going to do 12. Start doing 12 and finish it. 11 and 12 same. Only difference is G and W. Instead of G and W, there is 1 and 2. Start doing 12 and prove it and hands up. Finished 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 hands up. If you finished, hands up. If you are finished doing, hands up. Yes. Finished, hands up. Quickly, only one finished. Press quick, only 3 finished. Only 3 finished. Finish quickly. Only 3. 4 finished. Quickly, Absen, Hafna, Trifana, Senistika, Sharaf. Finish quickly. Hands up. Same thing, copy and paste. Copying. Same thing, copy and paste. Copy and paste. Copy and paste. Hands up. Hands up. Hands up. Hands up. Upnath. Upson. Hands up, hands up, hands up. Quickly, quickly. Quickly. Right? Hands up. Hands up, man. Hands up, girl. Girl and man. Hands up. Okay. Done. Right, okay. So then 13 story. 13. That's somewhat different. I'll give some time. Let's see how many of you can do that one. 13. 13. Starting 13. Hands up, Profis. 13 also. 13 also finish hands up. I'll give some time. Let's see how many of you can finish it. 13 finished hands up. 13 finished. 13 finished hands up. There is one. 13 finished one. I'll give some time. Just do 13. Just do 13. 11, 12. Last 45 minutes that you are going to stay with me. Last 45 minutes. Last 45. Again, we are meeting on next Sunday. No, next Saturday. Saturday. This is temporary time, not permanent time. Temporary time. Sir, can you explain again, please? What is that? What you want to explain? Two finished. 13 two people finished. 13 two people finished. 3 finished. Then do 14 also. 3 finished. I am also discussing. 13 they are telling us to prove refractive index of medium to relative medium 1. We want to prove refractive index of medium to relative medium 1 into refractive index of medium 3 relative medium 2 must be equal to refractive index of medium 3 relative medium 1. So when you look at this roughly, what you can see is what happened to the medium 2. This medium 2 has disappeared. Medium 2 has disappeared. 1 is at the top. 1 is at the top. Medium 2 is disappeared. Intermediate medium is disappeared. 3 is at the bottom. Better if we can start from left hand side. If you start from left hand side, you can get the answer easily. Start from left hand side. Left hand side. Left hand side. Remember, then refractive index of medium 2 relative to medium 1 into refractive index of medium 3 relative to medium 2. Then you can give standard definition in terms of speed ratio. Now you know, now one can use this relative refractive index stories, one can represent in terms of speed ratio. If not, one can represent in terms of refractive index ratio, absolute refractive index ratio. Different people can have different approaches. One can do absolute refractive index ratio here, and one can tell speed ratio. But the standard is speed ratio, therefore I'm going with speed ratio. Then top is C1. Absolute refractive index of medium 2 relative to medium 1 means top is medium 1 C1 over C2 into here top is C2, bottom is C3. Simple. Simple. C to C2 cancel out. What is remaining here? C1 to C3. Top is C1, bottom is C3 means top is 1, bottom is 3. Refractive index of medium 3 relative to medium 1. Left hand side equals right hand side. Very simple. Very simple story. The last one. Last one 14. Finish 14 also. 14. Finish 14. Finish 14 also. 14 finished 14. Refractive indices of water and glass. Now when they tell just refractive indices, they are the absolute refractive indices of water and glass for over 3, 3 over 2 respectively. The refractive index of glass related to water. 14 also finished answer. 14 also finished answer. 14 finished answer. 14 finished answer. 14 finished. 14 finished answer. 14 finished. Finished answer. 14 finished answer. Don't raise down. Hands up. 14 finished answer. Finished answer. Many finished. Simple. Now you know the idea. You know that. Look here. Look here. They have given refractive index ratio. Now they are asking us to find the refractive index of glass related to water. See, you want to find refractive index of glass related to water. See the story. Refractive index of medium 2 related to medium 1 equals absolute refractive index of medium 2 over absolute refractive index of medium 1. Now, if you are writing relative refractive index in terms of absolute refractive indices, 1 to 2 means 2 to 1. If it is speed ratio, look here. If you are writing the relative refractive index as a speed ratio, 1 to 2 means C1, C2, 1, 2. If it is absolute refractive indices ratio means 1 to 2 means 2 to 1. Remember that story. Absolute refractive indices ratio means 1 to 2 means 2 to 1. Speed ratio means 1 to 2 means 1 to 2. Then water to glass ni. They have given absolute refractive index of water and glass. I want to find the refractive index of glass related to water. Then top must be bottom, bottom must be top. Top must be bottom, bottom must be top. Ng over Nw. If you interchange, it's wrong, right? Now your top is water, bottom is water. Means top, bottom is glass, top is glass. Ng means what? 3 over 2 division. Nw means how much? 4 over 3. Then you simplify it, we will know that 3 over 2 division becomes multiplication, reciprocal. 3 over 4. Hands up, who got 9 over 8 hands up? Genuinely hands up, who got 9 over 8? Genuinely hands up. You got 9 over 8 hands up? 9 over 8. 9 over 8, genuinely. Be very genuine. Story finished. The story is finished. Relative refractive index fully finished. Now okay. Now first chapter is finished. Okay. You need some time to breathe. Do you need some time to breathe? Do you need some time to breathe? You guys want? You guys want something to breathe, man? Done? Done. Finished. So what shall I do now? What shall I do now? Hands up. Who want to stop the class now? Just raise your hands. Open it. Sir, I want to stop the class now, sir. Hands up. Sir, no. We'll continue the class until 12, sir. Hands up. Sir, we'll continue the class until 12, sir. Yes, yes. Just asked. I just asked. What's your opinion? You think that am I going to stop the class right now? No, 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 no. I will do until 12. Theory, man. Theory, right? When to finish the syllabus? Right? Can't stop the class now. You need some time to take a breath since we are doing continuously. You don't need a break also. Then next story. We'll go to next theory part. Next theory part. Next theory part. Feeling tired, answer? Sir, now tired. Sir, 8 to now time is almost 11:30. Now tired, answer. Genuinely. Genuinely. So now tired. So now I'm tired. Seriously, I'm tired. But I can stay more, but I'm tired. Hands up. So I'm tired. So I'm tired. No one. Wow. Great. Great, me. Then great. Okay. Right. Then great. Right. The laws of refraction. Already I told you the 2 laws of refraction. Remember, there are 2 laws of refraction. Now write down under first law of refraction. Write down. Under first law of refraction. Write down. Under first law of refraction. Write down. A different color pen. You don't want to use that color pen. Different color pen. Write down. The incident ray, comma. The incident ray, comma. The normal drawn at the incident point. The normal drawn at the incident point. The normal drawn at the incident point perpendicular to common interface. The normal drawn at the incident point perpendicular to common interface. And refracted ray. And refracted ray. And refracted ray. Should be in the same plane. Should be in the same plane. Should be the same plane. That's not a difficult story. Look here. Not difficult. Look at here. Look here. They are telling that incident ray and the normal and the refracted ray must be the same plane. Same plane. Right? I don't want to explain, right? Because now this is red color one is incident ray. I think red color one is incident ray. Raise your hands how many of you see this red color one is incident ray. Look here. This blue color one is your refracted ray. Raise your hands, sir. This red color ray and incident ray and blue color refracted ray, they are in same plane answer. Raise your hands how many of you say, sir, this red color incident ray and blue color refracted ray, they are in same plane answer. So they are in different planes answer. They are in different planes. They are different planes answer. They are in different planes. If they are in same plane, they same plane. Sorry, you know, I do not explain. Second law of refraction, that's what we want. The most important law is second law of refraction, highlights Snell law. So we are calling second law of refraction as the Snell law, highlights Snell law. And that in first law of refraction, highlight that same plane also, Snell law story. Write down, Snell law, write down, write down, write down. Write down. Write down. Write down. When there is a refraction between two mediums, when there is a refraction between two mediums, when there is a refraction between two mediums, comma, the ratio of sine value, the ratio of sine value of incident angle the ratio of sine value of incident angle the ratio of sine value of incident angle to the to the to the sine value of refracted angle, sine value of refracted angle, sine value of refracted angle is always a constant, 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 right? Okay, is always a constant, right? Okay, okay, right. Yes, okay, okay, okay. Now that below I have mentioned important. Okay, okay, I will explain. Snell law is very important. Second law of refraction is very important. This idea, very careful listen. I reach the boat, better reach the boat. I'm reaching the boat. The last half an hour. Hands up, who can stay for last half an hour? Hands up. Sir, no issue. We can stay focusedly till the last second. Hands up. So we can stay focused. Hands up. So we can stay focused. No issue. We can focus. No issue. 12 o'clock. We are finishing. No issue. Half an hour only. It goes like a rocket. We know. Okay. Great. Great. And today ready. 6 p.m. you have exam. 1 hour. 25 p.m. CQ paper. Ready for the paper. 25 MCQs. Your marks maybe comes low mark. Sometimes 10 MCQs only you got correct. 20, 15. Don't bother. Don't worry. Don't worry. Don't bother. Sir, I got only 5 MCQs out of 25. Sir, what can I do, sir? I'm going to stop A levels. Don't do bullshit things. Don't do shit types of things, huh? Right. Okay, Snello story. Snello story. So that means you are coming to tell that during refraction. So let's say medium one, medium two. So this is my common interface XY. Sir. So this is my normal. So I draw an incident ray. This is my incident ray. You can draw whatever the way that you prefer. So this is my incident. So this is my incident ray. This is my reference ray. Then this is my medium one. This is my medium one. Look here. Let's say speed of light in medium one is c1. Look here. Absolute refractive index of medium one is n1. Absolute refractive index of medium one is n1. Right? So then this is my medium two. Medium two. Medium two. So speed of medium two is c2. Absolute refractive index of medium 2, I mark it as N2. 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 So now see, did you notice now absolute refractive index, relative refractive index, they also don't have units or dimensions. Did I give that note? Did I give that not absolute refractive index I gave any? I give. Okay. Right. See, incident angle is I. Look at it very carefully. Incident angle is I measured from normal to the incident ray. Refractive angle is R measured from normal to the ray R. Okay. So that are you coming till Snell is telling that during a refraction, a light ray from medium 1 to medium 2, the ratio of sine value of incident angle. Sine value is the angle. Sine value of incident angle. Sine value of incident angle means sine I. He is telling, so sine I over sine value of referral angle over sine R. Sine R. Sine R. They are telling that this is always a constant. It doesn't matter when your incident angle increases. Remember, R also increases, and always this refraction ensures sine incident angle to sine R value always constant. This is always a constant. This is always a constant. This is what they do in Snell law. K means a constant. K means constant. Right? This Snell law says. Okay. Just write down this story. Write down the story below that important this ratio. Okay. Write this story. If not nearby, write this sine I to sine R is a constant K in that second law. After you wrote the second law, somewhere nearby, write this second law story. And there's a point important. Highlight. This ratio is the refractive index of second medium relative to first medium. Now they mentioned this ratio. Now Snell told that always sine I to sine R is a constant. Further, when they study this further, they realize that this constant sine I to sine R ratio is this constant sine I to sine R ratio is exactly equal to refractive index of medium 2 relative to medium 1. They are telling this constant. Okay. They are telling this constant equals refractive index of medium 2 relative to medium 1. This constant K equals to refractive index of medium 2 relative to medium 1. How can I write refractive index of second medium 2 relative to medium 1? That means what? In terms of, tell me, refractive index of medium 2 relative to medium 1. In terms of absolute refractive index, tell me this value. It's a constant. They finally found that constant is equal to refractive index of medium 2 relative to medium 1. In terms of absolute refractive index, telling me this ratio. Sir, it's n2 to n1. Absolute refractive index of medium 2 over, sir, absolute refractive index of medium 1, sir. Nice story. Nice story. Equation 1. Equation 1 is going to be equation 2. From equation 1 and 2, sir, we can write down like this, sir. Equation 1 and 2, we can write down, sir. Sin I to sin R ratio. Sin I to sin R ratio. Remember, sir, sin I to sin R ratio is equal to n2 to n1. Absolute refractive index of medium 2 over absolute refractive index of medium 1, sir. And then only we are deriving the most popular equation in refraction. Most popular equation in refraction. That is what? N2 to N1. The most popular equation in refraction. N2 to N1. Cross multiply. Cross multiply. We can write down. Finally, N1 sin I, N2 sin R. The most popular equation. Hereafter, we are doing calculations. Every calculation, we are going to use this equation. Snell law means mainly we are writing this equation. N1 into sin I must be always equal to N2 into sin R. N2 into sin R always equal to N2 into sin R. This is the most popular equation in refraction. Then the next popular equation in refraction is Lenz's equation. N2 sin R. Nice story. I hope you understood the derivation. Snell told it's a constant. Finally, they learned this constant is a refractive index of medium 2 to medium 1, N2 to N1. These are interconnected. These are interconnected. Without knowing previous story, you don't understand the story. If you properly understood all the previous things up to now, I don't think that you should understand, because I am teaching everything A to Z properly. Okay. I don't know whether you find a good place to learn when it comes to English medium classes. Normally, right? Qualified. Okay. In the given space, write the stories. In the given space, write the stories. Stories. Nice. So beautiful. So beautiful. Last 25 minutes. So nice. Okay, now you can go. No issues. You can leave, madam. Watch the recordings. Now, likewise, stay the session. And if you want to leave, just stay and try now. If you have another session, what you can do, you can stay the session. And when you want to go to the next session, time is okay, then just leave. It's okay. Some people, they don't join online, even they are free. Right. Right. Highlight. This is important. This is important. Highlight. Highlight important. Highlight important. Important story. Okay. The Snell law story done. Snell law story done. Right. Okay. Start doing question number 15, 16 now. Page number 11. Yeah, I want to give some. I missed some spaces. Tell me, remind me. Remind me if I skip any place spaces in between. Now start doing question number 15, 16. 15, 16. Start doing question. Now you read the logbook also. Start doing 15, 16. Start doing 15, 16. Start doing 15, 16. Quickly. Start doing. Hands up. Start doing 15, 16. Hands up. So I start doing 15, 16. Hands up. Start hands up. Last few minutes. Last few minutes. Stay with the same energy. The same energy. Again, next theory class is next week, right? Never make yourself lazy. It might be tired. That's obvious. It's obvious. And I'm also very, very tired now. But don't let yourself to what? Become lazy. Even it might be difficult. It's very difficult. You might feel the head pain, but that's okay. Somehow resist everything and stay focused. Practice your body, practice your mind to stay for long hours focused. When you become doctors, when you go for lecture halls, nee, if you don't have a focus, you don't even understand what they are teaching in universities. Finished answer. Finished answer. 15, 16 finished. Question number 15. Question number 16 finished. Answer. Now 15 they say that light ray travels from air to glass. If the incident angle is 60°, what is the refracted angle? Now you have to use this equation, Snell equation. 15, 16. 15 and 16. 15. I do a diagram also, then no need this diagram to get the answer. But I do the diagram also. Diagram. Then incident angle 30. The normal incident angle and then referred angle. That light ray is entering from AR to glass. AR is rare medium. We all know AR is rare medium. AR is rare medium. We all know glass is dense medium. Mention that. AR is rare medium. Glass is denser. Rare medium. Glass is dense medium. Capital D. Right? Then just now we learned that when light ray enters from rarer to denser, light ray bends towards normal. Do the diagram. It's okay. You just do the diagram. Nice. Light ray enters from rarer to denser. Light ray bends towards normal. Bends towards normal. So then angle measured from normal to the incident ray I, angle measured from normal to referred ray R, and they have given absolute refractive index of AR. They don't need to give. We know that absolute refractive index of AR. We learned it's 1. Absolute refractive index of AR. We know that is equal to 1. And we all know absolute refractive index of glass. That is, we know that Ng means what? 3/2. Then simple. They are asking. They have given incident angle is 30. We want to find the They have given incident angle is 60. I is 60. I want to find the R. I want to find the R value. I want to find the R value. I angle is 60 degrees. I is how much? 60. How do you find R? Snell law. We apply Snell law, Snell equation. Snell equation. N1 sin I must be equal to N2 sin R. N1 sin I must be equal to N2 into sin R. 1 and I, see 1 and I, medium 1 absolute refractive index into medium 1 incident angle. N2 means medium to absolute refractive index, refracted angle. N1 is AR. It is 1. Absolute refractive index of AR is 1. Sine 60. Sine 60 must be hands up who finished 15, 16, both hands up. Hands up who finished 15, 16. You should have a book. You should have a logbook. That sine costan book you should have. Hands up, anyone finished 15? 15 finished? 15 finished. 15 finished hands up. 15 finished hands up. Hands up who have that not logbook, sine costan book hands up. That sine cost, yeah, logbook only. Sine costan book hands up who have? You should have not the logbook, sine costan also. The next pages. Hands up who have? Tell me them because I want from you the answers. Therefore, please tell me the answers also. If not, we can't find the angles. 1 into sine 60. N2 means what? Second medium. That is glass. Dense medium. Glass. Absolute refractive index of glass is 3/2 into sin r. I want to find sin r. Sin r. Sin r. Target is finding r. Then we know sine 60 means we know root 3/2. Sine 60 means root 3/2. If you move this 2 and to this side, then 2/3. 2/3 must be equal to sin r. Sin r. Okay, sin r. My target is finding simple r only. So then it's a 2 to cancel out. Root 3 means we all know 1.732, right? Root 3 means 1.732/3. If I divide that, sir, 1.732/3 means sin r. See the idea. You want to tell me that now values. I also don't have a sine costan book. Next time I also keep one with me. If not, you can download in the internet. If not one, please share that sine costan, that table, only the sine table. Now, when you open the page, first one is log, second is sine. Someone share that sine page in the WhatsApp group. If you have the sine page in the WhatsApp group, someone share it. If you divide by 3, 1.73 divided by 3 means 0. 7 means 5. Then 15. Then 23 means how much? 7. Then 22 means again 7. 3. 0.5773. If we substitute R, finally, if I'm wrong, tell me. 0.5, then 15, 5, 23 means 7, 22 means again 7, 10 means 3. R means sine inverse. 0.5773. Now, I need your help. Go to the sine table from the middle. Go to sine table from the middle. Try to find 0.5773. Then tell me the corresponding angle in degrees and minutes. I want from you guys, tell me now, find 0.5773 in the middle. You don't get exactly 0.5773. Any closer value. Less than this value. Less than 0.5773, the closer value. Exactly same value you can find it. I want this angle, minute. Answer. What if you can remember how to find the sine, cos, angles answer? Just answer. Answer. Okay, remember answer. Answer. Okay, remember this sine. How to find the sine table stories answer? Genuinely, I don't know answer. Genuinely, I don't know. I can't remember. I learned in knowledge, but I can't remember answer. Be genuine, sir. I learned, but I can't remember. I can't remember many. That case I want to teach you. Right. Okay, 1150. I want to teach you, right? 1150. 1150. Right. 1150. Right. Okay. Right. 1150. Now, okay. Don't worry. I will teach you. Next day. Next Saturday. Everyone buy a logbook. Logbook you have. Sine costan table you don't have. I try to print and I'll post, but it will take time. What you do next day, buy a logbook and keep the logbook with you hereafter. Hereafter, the logbook with you. But people who have the logbook, tell me now, there are two people who know the answer. There are two people who told that, yes, I know the sign, cost, and stories. Tell me what is the answer, madam? R is how much? Now we almost 12. Madam, tell me the R is how much? I don't know. It's Akshada. Tell me the answer. What is the answer? Anishka. 35 degrees, 50 minutes. 35 degrees, 50 minutes. Don't worry. R is just write down. Even you don't, it's okay. Just write down R is 35 degrees, 50 minutes. Just write down. Okay, finished. Don't worry. I will teach you the story. I will teach you sine, cos, tan stories. Then you understand me? So is it 35 degree 15 minutes? Yes, yes. Simple story only. Nothing difficult. But I will teach you. Don't worry, next day. Generally hands up. The time is almost 12. 11:50. Session is very effective hands up. Session is very effective hands up. Session is very effective hands up. Very effective. Study well. Study well. Day by day improve yourself. Normally we had to do 4-hour class roughly. We are not doing 4-hour class. We are doing around 3.5 hour class. For a week we should do this time. I need to do more time. I need more time. Right? So you also should give a support. Then only we can finish it nicely. Study well. Then we stop the class for today. Today is 6 p.m. Exam is there. Then we have discussion is there. Get ready and come. Okay. Then see you. Okay. Bye. Next time I will teach you the stories. Time question stories. I will teach you. Don't worry. Finished. See you then. Bye. Tata. Bye bye. See you.